Hello, everyone. Welcome. Welcome. It is a great day. The sun is shining. It is not snowing. Life is good. I want to thank you all so much for coming today. My name is Charlene Hansen. I am a member of the League of Women Voters Door County Board. Protecting our groundwater is the second program in the Door County League of Women Voters Eileen Bohn Speaker Series. Today's topic is certainly one that Eileen would love and support. She was a lifelong advocate of protecting our water and keeping it clean. Before I turn you over to our moderator, I would like to give you just a brief idea of what the League of Women Voters is and what we do. The League of Women Voters is 100 years old. We are a trusted, nonpartisan, political organization. We never endorse a candidate, and we never endorse a party. But we do get directly involved in shaping important issues that keep our communities safe and strong. The League encourages informed and active participation in government in two ways. Our first priority is voter service. We encourage qualified people to run for office. We conduct candidate forums to help voters become better informed so that they may vote intelligently. We conduct voter registrations, and we work to increase voter turnout. Our second priority is to address issues. We work to increase understanding of major public policy issues and to influence public policy through education and advocacy. We study issues, we form positions, and we take action. The League is an organization of both women and men. We welcome new members. If you're interested in learning more about the League, we have right behind you an information table. There is our person at the table. So you can learn how you can become involved. We have League literature information. We have membership sign-up sheets. And if you're not ready to become a member, we have a non-member email registration so that we can keep you informed of social issues, of political issues, of action events, and events such as this that will come up that you would be interested in. And if all of that escapes you, know that you can go to our website, League of Women Voters doorcounty.org. So now I'd like to introduce you and turn the meeting over to Susan Kohout, who will moderate today's program. Hey, thank you all. This is a great day.
Can everybody hear all right? Okay. Welcome. Thank you so much for coming today. This is the second program, as Charlynn said, of our Eileen Bohn Speaker Series. We believe we have an important and timely topic to present to you by a group of terrific speakers, and the fact that we have this kind of turnout shows us that you think that as well. Eileen Bohn was a longtime member of the Door County League, moving here in the 60s and getting so involved that by the early 70s she was president of the local chapter. Even in later years when health intervened, not allowing her to be as active, She was always a voice of reason, calmness, and wisdom that could be called upon by current leaders for her flawless judgment and discretion. She was on my speed dial. When Eileen died, her family generously donated money in her memory to establish the Eileen Bohn Speaker Fund. The fund is being used to bring quality speakers to the county each year to speak on issues of importance to League. Eileen was very committed to a wide range of issues and worked hard over the years to promote good government. We are grateful to her family for helping us continue that work. Some of them are here today. We have a whole table. Second one in, raise your hand, the Bohn family. We've got her son Mark and his wife. I'm sorry, I don't remember your first name. Sarah, maybe? No? Okay. For today, you can be Sarah. Her sister and her husband and her niece. Did I get them right? Okay. Thank you so much for coming. It means a lot to us, and of course it would have to Eileen. We are also very grateful to some other folks, in addition to the Bohn family, for making this event possible. The Sturgeon Bay School District for the use of this venue, the media for publicizing this event and covering it today, Laddie Chapman, who has generously volunteered to videotape this program, which will be available on Charter Peg TV channel 986, he says as early as Sunday night, 7 p.m., he believes. You can find a link on www.doorbell.net/video also, and there will be links off of our Facebook and web pages. Finally, a thank you to all the many members of League who have participated. We don't do any events where it doesn't take an awful lot of hands and backs and feet and so on to get things done, and we appreciate everybody who has pitched in. And also, and especially, our speakers. 2 are here and 3 are, there they are, I see them, whom you will meet momentarily. Little housekeeping. If you go out this door and around the corner, immediately to your left, you will find bathrooms. Please turn off your cell phones. And there is a table with some materials that were brought by some of our speakers. Can you point? Helen, is it right there in the back? Okay. Our morning schedule will begin with presentations by Dr. Maureen Muldoon and Dr. Mark Borchardt. Then we'll take a brief break to refill our cups and plates, and about 10:45 we'll turn to our panel of local experts who, as our boots on the ground, will explain local efforts to address groundwater issues. And then finally there will be time for questions. Surveys of Door County residents year after year have identified groundwater protection as high on the lists of concerns they have for the future of their community. Local governments and citizens groups have worked hard to take steps to protect this resource. Our first 2 speakers have spent years studying the effect of various practices on groundwater in northeast Wisconsin, and will share their research, which demonstrates why these citizen concerns are justified by the fragile geology of our peninsula. Our first presenter, Dr. Maureen Muldoon, who is a professor of geology at the University of Wisconsin, Oshkosh. Dr. Muldoon joined the UW Oshkosh Geology faculty in 1998 and teaches undergraduate courses in hydrogeology, environmental geology, and does occasional field trips. Her research focuses on groundwater flow in fractured carbonate aquifers. Recent projects focused on groundwater quality in Kewaunee County and the role of groundwater in various wetlands in Door County. Before joining the staff at UW Oshkosh, she was a hydrogeologist with the Wisconsin Geological and Natural History Survey for almost 11 years. Our next presenter, Dr. Mark Borchardt, has had a very busy month. Our event will be his 5th presentation in the month of April.
I didn't know I told you that.
You did tell me that. Is it okay if I tell them?
Number 6 is coming tonight, actually.
Oh, wow. He has presented his talk on cows or people, sources of fecal contamination in northeast Wisconsin groundwater at Cornell, Stanford, Geological Society of America, and Luther College before coming here today. That's just in April. Where are you going tonight?
That's a personal subject dealing with trying to fight a pipeline company from taking my home.
Oh, good luck. Dr. Borchardt is a research microbiologist for the USDA Agricultural Research Service and program leader for the Laboratory for Infectious Disease and the Environment, U.S. Geological Survey, Wisconsin Water Science Center. Dr. Borchardt's expertise is on the measurement, fate, transport, and health effects of human and agricultural zoonotic pathogens in the environment. Recently, he received the Dr. John L. Leal Award from the American Water Works Association for his work on improving water quality and protecting public health in the United States. We are very grateful to have both of these experts with us today. All right.
Susan, would it be okay if we turned off the lights? You think that would?
Yes. Helen,
Tripping.
can you turn the lights?
I think well.
So when Susan talked to me, she asked if I would sort of address some of the geologic issues about groundwater in Door County. So the focus of this is going to be why is Door County particularly vulnerable to groundwater contamination?
Excuse me, would you please bring up behind the podium, or I won't pick up the
Okay, it's just easier to see out here, but I can go back. There we go. No, he needs this one, so I kind of do need to be here. That's okay. It's harder to point, but that's okay. No, I'm good. Okay, but I can answer the question of like, why is your county so vulnerable? It's basically two things, and then we can all go home. It's your bedrock geology, and it's thin soil cover. And there's not really anything you can do about that. That is the geology of your county. Why does thin soil cover matter? Well, if you think about things we do at the ground surface, we rely on that soil cover to essentially filter out any water moving from the ground surface to the aquifer, and we're trying to remove contaminants, trying to remove the pathogens that Mark's going to talk about. And if you don't have any, if it basically just runs and goes into a big crack, you don't get any of that filtration. So the soil thickness is really critical in terms of protection of groundwater. And we do lots of things at the ground surface. We have septic systems, we apply sludge to fields, we apply animal waste to fields, and we need that soil cover to kind of do that treatment process for the water. And in areas where it's thin, it basically just doesn't happen. Okay, so I purposely, this is pinned to my bulletin board at work. I use it all the time. It's actually a publication from your county called Protect the Water You Drink, Tip for Homeowners from rural homes and agricultural lands in Door County. Basically, I was looking for a map that shows soil thicknesses in Door County, but the soil is less than 18 inches deep in almost a quarter of your county. Okay, another 17% of the county has between 18 and 36 inches. That's not a lot of soil cover, right? Where I live, it's 60 feet of sediment over the bedrock. Okay, so you have very thin soil covers. And like I said, if you're interested in learning where you live and what your soil thickness is, you should pick up this. There was a whole box of them right there that I stole that out of because I forgot to bring mine. Okay, so what are we going to talk about today? I just want to talk about the geology of the Silurian dolomite aquifer and sort of what does that mean for groundwater flow patterns and characteristics. Focus a lot on the idea of groundwater recharge, which is how water gets from the ground surface into the aquifer. Look a little bit at existing water quality data because you guys have a lot, right? There's been a lot of work done in Door County, and then I'll summarize. Okay, so the Silurian dolomite is, of course, up here in Door, but it lies along the entire east side of Wisconsin, goes up through the UP, wraps around. It's exactly the same rocks that make Niagara Falls over here, and then come back around, right? And so up here in Door, there's just very little soil cover over that aquifer, and as we move south into the state, that soil cover thickens a little bit. That's what it looks like. That's from a quarry just up the road in Sturgeon Bay. Nice, it looks relatively flat-lying rocks, lots of sedimentary layers. It's dolomite, so limestone that's been changed a little bit, formed in an ocean basin. One of the characteristics, is it better, is that good? Okay. One of the characteristics I want to note in this picture is that this rock is extensively fractured. So there are vertical fractures that you can see here, 2 sets, and there's bedding plane fractures. And it is through those fractures that the water primarily moves. So this is across from one of our old research sites. This is an alfalfa field. And you can see the expression of those fractures really easily, because in this particular field there's only about 18 inches of soil, and in the cracks there's a little bit more, so the alfalfa's kind of happy in the cracks, not so happy over the blocks. This is oats. Those fractures don't stop, you just don't see them. But when you think about what does the rock surface look like in all of Door, it looks like that. There's fractures everywhere. That's my foot, there's the soil thickness, there's the fracture. That's in the wooded area. Big open fractures. This is the C&M sinkhole. All of this water drains through this roadside ditch, goes into this sinkhole, and just vanishes into the ground. This is the lack of filtration for water entering this aquifer. Okay, so those are some of the vertical fractures. What does it look like in the ground? And these are kind of odd pictures if you're not used to looking down boreholes. This is a 3-inch well, and we're lowering a television camera down that well, and it's got a bird's eye view. So you can see, here's an open bedding plane fracture that is intersecting that well. This particular camera had a way that you could take the lens and turn it sideways to look at the wall, and there's big open fractures in your groundwater aquifer. We found cherry pits in there. Okay, big things, chunk transport in your aquifer. Okay, this is, somebody just sent me this, and so I wanted an excuse to use it. This is a sort of a diagram of what a karst aquifer looks like from Nancy Eaton, Landscapes of Place. This would be Green Bay, so Lake Michigan would be over here. But this is a pretty nice representation of sort of how things at the ground surface can affect the groundwater. You have very deep through-going vertical fractures, and then lots of bedding plane fractures in that aquifer. Okay. Groundwater concerns in Door County aren't really new. This is a slide I got from Ken Bradbury when I started working at the survey in 1987, so 30 years ago. And some of these were from things that during his PhD in the early 1980s. So the vulnerability of Door County's groundwater has been known for a long time. Okay, so what do we know about your aquifer? There's a dense and ubiquitous fracture network. Fractures are everywhere. There's very little surface runoff. It infiltrates to the aquifer very quickly. And as it does so, that process, we call that recharge. It's exceedingly rapid. It goes very fast, and we're going to look at the recharge process in a little detail. It also carries surface contaminants into the aquifer. The flow in the aquifer is primarily along those bedding plane fractures, and you're getting some dilution of contaminants, but you're not really getting filtration the way you might in a sand or a sandstone type aquifer. So there's little to no attenuation or reduction of contaminants. And the flow rates are very fast. I mean, average velocities are on the order of tens to hundreds of feet per day, but there are times of the year where that can be thousands of feet per day. This is not normal for groundwater, right? Normally groundwater moves hundreds of feet per year in most other aquifers. So you have a very flashy aquifer where the flow is very rapid, and that has implications for your groundwater chemistry and how that chemistry is going to change over time. Okay, so let's look at the water cycle. I'm sure we all did the water cycle at some point in middle school or someplace, but it's good to think about it again. And sort of just think about the water cycle, and then how does that affect recharge, and what times of year do we have recharge, and those kind of questions. So just some definitions first. What is an aquifer? Any geologic unit that can store and transmit water. The water table, little arrow here, is basically the dividing line between what we call the unsaturated zone and the saturated zone. And so in the unsaturated zone, the pore spaces between the little sediment grains or the fractures in the rock, they contain both air and water. It might be moist, water might be coating those grains and stuff, but if you dig a hole, it's not going to fill up with water. If you go below the water table, you hit the saturated zone, and then all of your pore spaces are totally full up or saturated with water. And so that's what that would look like in an aquifer. Groundwater recharge then is the process of water going from the ground surface to the water table. And if we think about the water cycle, water infiltrates into the soil zone, and sometimes it doesn't make it all the way down to the water table. It gets used by plants and it transpires back out. There are other times a year where that water is just going to go right in. Right? So how do we look for those events? Nice little water cycle picture from the state survey. Evaporation and transpiration are the things that water infiltrates, but is it going to make it to the water table? Well, when you have everything fully leafed out and all the crops are on the fields, we don't really get much recharge. during those times of year, during the growing season, the water table levels are generally declining. Okay, so then what happens? Well, in the fall, trees drop their leaves, crops get harvested, not a lot of transpiration's going on, right? That's a time of year, so fall time of year, that's a good time of year for groundwater recharge. If it's a wet fall, that water will go in. Now during the winter, we get snow, and more snow, and more snow. And that water is sort of stored on the ground surface. But if we have little melt events, then it's gonna go in. Right? And typically, the spring snow melt event is our biggest period of groundwater recharge throughout the year. That's when all that water is sort of moving into the system because it's not getting used by plants. So recharge varies seasonally, right? And how do you look for recharge? Well, there's the obvious one. The water levels in the wells go up because water's getting in there. That's one thing you can look for. The other thing you can look for is changes in water temperature or chemistry. So groundwater is sort of your average annual air temperature. So in centigrade, 8 to 10 degrees centigrade, 40s, 50s Fahrenheit. Rain and snow is colder, right? So we see a change in temperature when that's going in, and we can monitor that to sort of watch for recharge. Okay, so I'm going to show you some just historic data from a study we did at the state survey when I first started way back in the 80s and 90s, so people have been looking at your groundwater for a long time. This was a study area that was 3 miles by 5 miles. You're going to see some water quality results from that later. Right now, we're going to look at some water levels from what we call the Jarman Road research site, because it was on Jarman Road. Very creative in our naming. So these are a number of wells at that site. So there's some shallow wells and some very deep wells. These are water levels from the time period of January of 1987 to October of 1990. And what you see, we're just going to look at the deep ones. You know, this is that fall recharge event. Water levels start to rise. We have a cold January, they drop. They peak up in about March. They drop all the way through the next year till fall. A little bit of recharge, dropping in the winter, recharge, dropping. Okay, these are huge water level variations. This is 630 feet. That's 730 feet. The water table fluctuation in that well was 100 feet. I mean, that's sort of crazy variable, right? We don't normally see those levels of variation. Okay, so there's huge water level variations, and there's very rapid recharge during these time periods, but not recharge here. And that matters in terms of when we want to think about how do we go about protecting the resource. If you're putting things out in the landscape, if it's not a recharge period, it's not going to flush in as long as that nutrient or whatever gets used up before the next big recharge cycle. Okay, so we're going to look at 2 examples of recharge to deeply cased wells, because these are the ones that struck me most about how vulnerable your groundwater is. And so one of these is coming from the Sturgeon Bay Wellhead Protection Project that was done back in the early 2000s. This is the pumping well here that we're going to talk about, well 6. And we had a monitoring well up at what was the highway garage and is now something else now. It's a USGS monitoring well. There's a rain gauge at the experiment farm, and this was that research site I just showed you. We're going to look at what's happening at this particular well during recharge. So this is what we called the highway garage well, but it's not the highway garage anymore. Things change indoor. The well is cased to 170 feet, which means that metal pipe that you guys see in your yard, it goes down to 170. And then below that, it's just open rock wall into that well. Now we did things like you can take a tool and put it down the well to measure borehole diameter, and it sort of kicks out where there's a fracture and then comes back in and kicks out. And it's called a caliper log, and it shows you the diameter of the borehole. So these big kicks to the right are where you have big bedding plane fractures. We also did a bunch of fluid logging in this well to see where water was coming in, and the arrows indicate points where a lot of water enters the well. So we put our measurement device right here, so it's sitting about 280 feet below the ground surface. The water table's way up here. It fluctuates between 20 and 40 feet. So when I talk about recharge to this well, the water has to go through 20 feet of unsaturated zone, over 200 feet of saturated aquifer, and then come over to my sensing device. And what we see is that it responds within 24 hours, which is sort of crazy fast, right? I mean, really crazy fast. So this is a record from 1999 to 2000. What you see here are precipitation events, like this would be a nice 1-inch rain event. And when that rain event happens, the gray line here is the electrical conductivity. fluid conductivity is a measure of how much total dissolved stuff you have in the water. The more dissolved stuff, you can think about it as salt if you want to, there's more ions, and so the currents move more easily. Rainwater doesn't have much dissolved stuff in it. Groundwater has a lot of dissolved stuff in it because it's moving through the rock aquifer. So you have this rain event, and within 24 hours, you see a drop in conductivity, which is, like I said, that's really, really fast. Right? So you can always say when it's just one well, maybe this well, maybe it's bad construction, maybe the casing's bad or something, right? So we're going to look at another example. This would be a Kewaunee County example, where we're going to look at a deeply cased homeowner well. Okay, so this is the homeowner well. It's a brand new well, so we can presume good construction. It's 300 feet deep, and the casing goes down to 200 feet. Okay, we measured for recharge at some non-pumping monitoring wells, down here by the fish hatchery and up here at an old research site well. And we're looking at water levels and water quality again to indicate recharge. Okay, so just what did we see with water levels? Mark's going to talk about other stuff with this project. I'm just going to talk about recharge of this homeowner well. So this is the time period of November of 15 to July of 2017. The areas I've colored blue are generally recharge periods, declining water levels, recharge periods, declining water levels. During much of our study, we had a very wet, warm winter that year. So you have overall recharge punctuated by these big spikes of really rapid recharge. Okay. So what did we see at this site? And I'm going to just do sort of one example. This was a rain event in October of 2016. This is hourly rainfall precipitation data. The rain event starts at 8 o'clock. I start to see the water level rise in my monitoring well at 1 o'clock. There are some chemical indicators that we're using to see if recharge is happening, and specifically what we're looking at is that fluid conductance and dissolved organic matter. Okay, so, and this is at the homeowner well. So what we see is we see an inflection here, and it peaks about 30 hours into the rain event. And this is what we saw in terms of pathogens at that homeowner well. Mainly we saw a lot of total coliform. This is a log scale, so it's 1, 10, or 100. And we see this kind of breakthrough curve of total coliforms, and it's coming through at 30 hours. And it's coming through into a well that's cased 200 feet deep. So I mean, it isn't just that the well and door was weird and had bad casing. This is just what this aquifer does. Okay, and the other thing indicating dissolved organic matter at the person's house was these were the samples we collected. Clearly dissolved organic matter is coming through. Actually, not a lot of pathogens. This is not your typical brown water, but it is dissolved organic matter. Okay, so we can sort of look at that at longer time frames. So this is January and this is April of that year. These are water levels at our monitoring wells indicating recharge periods. And then you can look at what's happening at the monitoring well and what's happening at the homeowner well, and you see very similar trends. And you can start to ask the questions like, does this happen all the time? Does it take a really big rain event to do this? Those kind of things. I would like to point out that at our monitoring well, where we're detecting these pulses, right, it's 7 feet of soil, and the well's only, casing goes down 10 feet. The well's only 33 feet deep. This is the fish hatchery monitoring well. The homeowner well is cased to 200. So your aquifer, the nature of the fractures in your aquifer allow that very deep, very rapid penetration of water from the ground surface. Okay, we're going to skip over this because I mainly want to focus on other things. So recharge to the Silurian. We know that it gets in really fast. We've done a lot of work in Door, and people had questions like, okay, if that's the way it works in Door County, everyone knows the soil's thin up there and it's kind of weird. What about the rest of northeast Wisconsin? So then we did a recharge study that looked in a well in Brown, Kewaunee, Calumet, and Manitowoc, and we saw the same thing. So recharge happens within a day or two, even if you have sediment thicknesses up to 18 feet, and even if the depth to water is up to 50 feet. So it gets in really fast. When we look at other parts of the upper Midwest, what you see is if you have cohesive soils, and by that I mean if you take a ball of soil and you clump it, it stays clumped. It doesn't fall apart the way a sand would, right? So you have cohesive soils. That means you can develop macropores, things like worm burrows or fractures in the actual sediment, right? that stay open and allow this rapid transport through the sediment. This is an example actually from Dodge County. It's a different dolomite aquifer, but they had a spring melt event. It was like February. A lot of manure ran to and ponded in one corner of the field. It sat there for a day, and then it like broke through, and then a bunch of wells turned brown, as you guys know about brown wells. And so the soil scientists went to go look at this. This is 15 feet of clay. It's like, how does it do that? Well, looky, those are worm burrows, and the brown is what you think it is, right? So I mean, clay isn't protective if there's big holes through it, right? And so when we think about what are our soils, we have to think not only about the texture of the soils, but also whether they can have these large open fractures and passageways. Okay, let's go look at some water quality data. I'm going to look at sort of how variable your water chemistry is, show some data from the Northern Door Priority Watershed Project, and tell you where you can go get data about your area if you're interested. Okay, so I showed you this picture of water level variations before from our research site. If the water levels go up and down that fast, that means the chemistry is going to be pretty variable as well, right? So let's go look from that same project. We monitored a number of wells, the Northern Door Priority Watershed Project, and I'm showing you nitrate data from 3 homeowner wells for the time period of 1986 to 1990. Okay, so here's the water level in the deep well at our research site. Here's people's nitrate values, 3 different wells. You see some similar things, like they're all spiking up right there, right? This is telling you it's not a point source. It's not the manure pit or the bad septic system. It's an aerially diffuse source that's being reflected in all of these homeowner wells at the same time. So that's one thing. You have a sort of a aerial source, right? These are miles apart. The other thing to notice is, let's just pick this well. Here's the drinking water standard of 10. Sometimes it's way below it. Sometimes it's way up to 30. So as a person who might have a well, and you take your annual sample and you feel good about it because your nitrate's good, it's not going to be that tomorrow or the next day or the next day, right? So you have to be very conscious of sort of what's happening in the landscape and which times of the year are vulnerable, because sometimes are more vulnerable than others. Okay, so like I said, since we're seeing a similar response, it's a non-point source of contamination, and also your water quality is really variable. Okay, so like I said, people have been looking at Door County a long time, not just me, other people. This is Marv Sherrill's paper from the 1970s, Geology and Groundwater in Door County, Wisconsin, with emphasis on contamination potential in the Silurian dolomite. After Sherrill's work, it was proposed that, normally for normal well construction into a rock aquifer, the state rules, which used to be NR 112 and are now NR 812, it would be 40 to 60 feet of casing into the rock, depending on how thick your superficial materials are. That's the standard for the state. In Door County, you have deeper, right? So as of 1971, Door County has a special casing requirement, and it varies depending on whether you're in the south or the north, of either 100 feet of casing into the rock or 170 feet of casing into the rock. Mark's been working, we've both been working down in Kewaunee County. Some people say, well, maybe we can just case deeper and it'll all be better. But we can sort of look at historic data we have to say, is that true or not? Right, so this is the Door County Priority Watershed data, which Bill helped with for a long time. This was 1986 to 1992, so about a 6-year project altogether. We started with 72 wells that were sampled biweekly, every other week. It was reduced to monthly, and then we dropped down to just 15 or so wells that we sampled out for 4 years. There's also some spring sampled, these are blue. And this was actually sort of a heroic feat. These data were in our base database. Nobody uses this anymore. I managed to extract it. I didn't have GPS coordinates. I called the nice GPS, the Geographic Information System guy in this county, because I could not get it to plot on a map that was in Door County anywhere in the world. It was all over. He figured out that we had dropped a digit off the front end of the coordinates because in 1986 you didn't have much storage space, right? But he transformed it, gave me the right coordinates, and I made my pretty map. So yeah, that's what happens when you have old data. So these are wells in green that complied with that 180 foot of casing. The red wells were not code compliant, and then the black ones we just didn't know. Like, you can't always find a well construction report. Okay, so what did we see? I'm going to look at a couple different water quality parameters. So for nitrate, which is one of the things that is standardly sampled for, the black numbers are wells that have 170 feet of casing. The red are wells that are less than 170. And so you can look at, there's 24 sites, 600 samples, 12 sites, 250 samples. Here's the minimum, here's the maximum, here's the mean, here's the standard deviation. They don't look all that different, right? You can do it for nitrate, you can do it for turbidity, you can do it for fluid conductance, chloride, and total coliforms. And with coliforms, it's just a % positive number. Now, tables are kind of boring and hard to grasp visually, so I made a little pretty graph. Okay, these are called box and whisker plots, where that is the median value for each set of samples. So in this case, the left ones are meeting casing requirements, the right ones are not. And there's some statistical difference there. And then this is like a standard deviation, and then these are outliers, right? For turbidity, there's really no difference. Chloride, there's really no difference. Conductivity, there's not a lot of difference. And total coliform, actually, the wells with good casing had higher % detections than the ones without. So there you go. It doesn't really seem to matter. Okay, so if you have a well here and you would like to know about your well, how can you get information? UW Stevens Point Center for Watershed Science has made this great online tool called the Well Water Quality Viewer Private Well Data for Wisconsin. They have conducted hundreds and hundreds and hundreds of sampling programs in towns throughout the state. And basically what they do is they sort of anonymize the data to a square mile, so you can't identify specific wells, and then you can go through and look at things. So it's an interactive program. You can look at groundwater quality. What I'm showing you here is by county, % of wells with bacteria detections. Red is greater than 25, orange is 20 to 25, yellow is 15 to 20. And you see, Door's kind of high, but there's certainly other areas that have a lot of bacteria too, okay? But the thing that's kind of cool about it is you can do it at the township scale, or you can do it at the section scale. And it also helps highlight things like there's a lot of data up here, there's not as much data down here, because not as many people have sampled. So like going forward, if you're thinking like, well, where do we want more data to kind of know about water quality, you can use this as a way to kind of say, where do we have a bunch already, and where don't we? Okay, so let's summarize. The geologic setting is what makes Door County especially vulnerable to groundwater contamination. You have thin, cohesive soils over fractured rock. It just is what it is. There's been like a lot of investigations in Door County. Just the state survey, because I've been a part of these, there's been a dozen projects since 1987. Like, you've had a lot of groundwater studies in Door County. And what have they shown us? Like, we actually understand how the aquifer works pretty well at this point. There were some learning curves steep in those early projects, but we're getting good at it. You have really rapid recharge, and that's taking surface contaminants in. You have fracture flow within the aquifer, and that's primarily occurring along bedding planes, and it gets really rapid flow rate, so tens to hundreds of feet per day on average. And there's, other than dilution, there's not a lot of attenuation of contaminants within the aquifer. I've got a couple slides of the different projects that I'm going to click through really fast, just if you, so you can know, there's like, that's the Northern Door Priority Watershed Project. We did a wellhead protection project for EPA. We looked at barnyard monitoring. We did numerical modeling. I did my PhD, the tracer study. We looked at how the geology controls the aquifer properties. We did a wellhead protection study. We did build on to that. We looked at how fractures form, and now we're doing a lot with wetlands and the Nature Conservancy. So Mink River, and then this one is with Dave Hart and the Nature Conservancy. So you've, like, people have looked at your groundwater a lot. And these are just projects I did. Milwaukee's done a bunch, Green Bay's done karst mapping. So you have a really good database to start from as you move forward to look at how do we do this protection. Okay, any questions before I let Mark talk? Yeah.
So your
Okay,
water.
hold on. We have a technical glitch regarding questions. So what we need you to do is, we'll both listen, we'll hear your question, she'll repeat it into there and then answer it, because otherwise it's not going to get picked up by our videotape, among other things.
So in your water chemistries, did you ever test iron in some of these wells?
Yes, I just didn't show it to you. Oh, so his question was, did we ever test for iron in these wells? And so routinely we tested for nitrate and bacteria, but we also sometimes did total anions and total cations and looked at iron. I just didn't, those are not usually indicators of surface contamination, so I didn't summarize them in this table. But we probably do have some data on iron, yeah. And certainly the UW Stevens Point database, that's one of the things you can look at.
Thanks, Maureen. So she gave you background on the hydrogeology of your situation here in Door County. I'm going to talk about microbiological quality and the study that we've been doing in Kewaunee County, Maureen and I and a number of other peoples. And so we're going to talk about cows or people, fecal sources, and risk factors associated with private well contamination in northeastern Wisconsin. Some of you, I'm feeling a little bit like a band here. Some of you have been to several of these talks. I have my groupies here. What I'm going to do for this is I'm going to highlight areas that are different, new information. And I can tell you where things stand right now is that we're working on the scientific paper, should be done in the next month, and we'll submit it at that point. So this has been a large study, number of people involved, Maureen, Sue Spencer, my group, Randy Hunt is another PhD level hydrogeologist, Joel, Erin, and Dave, Davina Bones, some of you know, she's been a crucial member of our team, head of land and water in Kewaunee County, and Bernie Kiki is the statistician on the group. And we have to thank all the households in Kewaunee County that allowed us to do the study and allowed us to take water samples. 621, I think that's about 12%, roughly 12% of the households with private wells in Kewaunee County. We need to thank them. So let's cut to the chase. The difficulty in Kewaunee County has been, where is the fecal contamination coming from? And when Maureen and I started this work in 2014 with some pilot data, it's fairly acrimonious debate about what's the source. And one source that's been pointed at is the cattle in Kewaunee County and the dairy industry. There's 97,000, close to 100,000 cattle and calves, about 45,000, 46,000 milk cows. There's 15 dairy CAFOs, 1 beef CAFO, maybe that's changed now. And if you do the math for the number of cows and how much they excrete in manure and urine, you end up with 700 million gallons per year of manure. And that's almost 100% of that spread on the landscape. So that's how much cattle waste there is in this county. But we don't want to forget about the other large mammal on the landscape, Homo sapiens, people, us. And that is Kewaunee County is a very rural county. There's not much in the way of sanitary sewer systems, municipalities, so there's septic systems. And this is a plot, if you can see the little red thing here. This is the county, here's Lake Michigan. Each of these dots, this came from the zoning office, each of these dots is a septic system. Primarily at-grade, or excuse me, drain field conventional septic systems. And if you subtract off the 540 holding tanks, and Lee left in the audience, I'm not sure where Lee is right now, but Lee helped me do the math on this. We kind of went back and forth. If you subtract off the holding tanks, assuming they're working and retaining the waste, and you subtract off the 155 abandoned systems, and you multiply by 2.47 people per household, which is the average in Kewaunee County, and the average water usage, you end up with 200 million gallons of household waste that's released to septic systems. And working septic systems, contrary to popular belief, working septic systems release the effluent to the environment. There's no magical treatment here. It's released to the subsurface. So we've got 700 million gallons of cattle waste, 200 million gallons of household waste. It's not quite an apples-to-apples comparison, because you know that for households, it's not all fecal waste. It's also dishwashing, showers, those sorts of activities, right? Baths. So that's been the two sources, and we're going to try to address this, where it's coming from in the groundwater. So for this project that Maureen and I wrote 2 proposals, funded from several different groups, one being the Wisconsin Department of Natural Resources. We had 3 project objectives. First of all, we wanted to estimate the county-wide contamination rate based on standard indicators of sanitary quality, that is coliform bacteria. Maureen already mentioned that term. So coliform bacteria have been an indicator in the United States since like 1914, 1909, somewhere in that area. They're not pathogenic, but they just tell you that some bugs that shouldn't be there are getting into the groundwater. And you find them in fecal material, but you also find them in soil. And then nitrate, you know, nitrate is a contaminant in the sense that it can cause blue baby syndrome. High levels, whenever I say high, I mean greater than 10 parts per million. Above 10 parts per million, you can get a syndrome called methemoglobinemia or blue baby syndrome. It's also been associated with some cancers, and it's also been associated with reproductive problems in women. So we're going to try to estimate the contamination rate for those two things. After that, then, we determine the source of fecal contamination using viruses and markers that are validated for either human or bovine. I'll get into that in a second. And then lastly, and the part that's primarily new for those of you that have heard some of this in the past, is we've used statistical models to identify the risk factors for contamination. That is, what things are happening on the landscape that result in contamination to these wells. So let's look at the first objective first, and that is this countywide estimate. So whenever, and Maureen already somewhat addressed this, whenever I talk about depth to bedrock, what we're talking about here is this soil layer or glacial till over this fractured rock. So this is depth to bedrock. So some cases you can scratch your foot in Kewaunee County and be at bedrock. Other times it's 100 feet or more. But depth to bedrock refers to this. For this sample, we randomized, out of the close to 5,000 wells in the county, we randomly selected as many as we could for sampling, what we could afford, and we stratified by depth to bedrock. 0 to 5 feet, 5 to 20, and 20 plus feet. What do I mean by stratified sampling? That is, from each of those depth to bedrock categories, we picked out the same number of wells randomly. Because what if by chance we picked all of them out of the 0 to 5 feet? We'd say the contamination was this rate for the whole county, when in fact it's not true. We did this twice, and we did it with what we call synoptic sampling. That is, instead of doing this over the course of a month, we try to do it in as small a time frame as possible, 2 to 3 days. We did it twice. We did it during groundwater recharge in November of 2015, and we had 317 wells in the analysis, and we also did it during a no recharge period in the summertime in July of 2016. Our participation rate was very high, 50%. These are people that just got a letter and a phone call from us, and they agreed to be participating in the study. So what did we find? Well, let's look at this table right here. So this is the percent wells contaminated. This is the countywide contamination rate weighted by depth to bedrock. When I say weighted, what I'm talking about here is the number of wells in each of those categories. I'd like to say that this, for the request for proposals, what the DNR put out, what they wanted us to do, this is standard research stuff. The funding agency asked for a specific objective. This is one that they wanted, the countywide rate, because they were afraid that it was biased. So that's why we did this, and that's why we use this fairly sophisticated sampling design. So what we see for total coliform, right here, recharge, no recharge, and then here's the statewide average from a government accounting office report from 1997. So for total coliform, 21% during recharge, 22% of the wells contaminated during no recharge. The statewide average is 23%. For E. coli, 0.4%, 1.2, 2.6. High nitrate, again, whenever I say high nitrate, I'm talking about greater than the maximum contaminant level, greater than the health risk, 10 parts per million. So for high nitrate, 7.4% during recharge, 6.8%, 6.6% in the county. Does this strike you as odd? It's not different. Kewaunee County, it's not different than the state. So 21% versus 23%, 7.4% versus 6.6%. You can't aggregate at the level of county. So while we met what the DNR wanted, that is an accurate estimate of the countywide rate, what we're ignoring is that effect to bedrock. So if someone tells you that the countywide rate is the same as the state, regardless of the county, you have to think about the hydrogeology varying across that county. So let's look at that now. Now this is a little bit of a complicated plot, and I want to spend time explaining it. I know it's Saturday morning. Maybe you've had only 2 cups of coffee instead of 3. But you gotta get the brain going here. And I'm going to have a number of plots like this, so I'm going to explain it now. And I think I like Maureen's analogy, given all the snow we've been dealing with. So you wouldn't be surprised if you saw a plot on the y-axis where it said snow depth in your yard, right? High snow depth, low snow depth. And then down here was temperature. High temperature, low temperature. You know that the higher the temperature, the lower the snow depth, right? And you could plot that in your yard, and you could plot that, and you come up with that relationship, right? So everyone understands that. It's no different than we talk about the probability of detection. Except, snow depth, you could say 1 inch, 2 inch, 3 inch, etc. For probability of detection, when we talk about an outcome here, it's about yes or no, there or not there, detect or not detect. And we can model that too, no different than the way we take temperature versus snow depth. So what you're going to see in this series of plots is the probability of detecting something. In this case, it's total coliform, that coliform bacteria. You're also going to see the probability of detection, a human marker, a manure marker, etc. So that's going to be on the y-axis, and always on the x-axis down here is going to be our risk factor. So we're going to look at a number of them. This is one that we just talked about, depth to bedrock. 50 feet to depth to bedrock, 100, 100, and 200. This blue line is the best fit to the data. And then, sorry to get a little wonky here, but the red lines, these are the scientific way of saying how confident we are that that blue line is in that area. So we're 95% confident that that blue line is somewhere between these two red lines. And when you see the red lines get wide, that tells you there's a lot of variability, and when you see the red lines get narrow, that tells you it's very tight. There's very little variability in the data. So what this is saying, for total coliform in our study in the fall, 315 wells, this p-value, I don't want to get into that much, but this is highly statistically significant. So the deeper you go with depth to bedrock, the lower the probability the contamination of total coliform. Depth to bedrock is incredibly important. So if you have a well with 150 feet depth to bedrock, you're only at about 10% chance of having a total coliform hit. If you're at a depth to bedrock of only about 10 feet, you're almost close to 40% chance of having a total coliform detection in Kewaunee County. This is the statewide average right here, 23%. So this statewide average I'm reporting to you doesn't vary with, I'm not reporting it as a variant of depth to bedrock, just what the statewide average is. And I'm not saying 23% is good, it's just a reference point. It's just a reference for us to compare Kewaunee County. So that's saying that at 50, you need to be at 50 feet, right here. This is where this intersection is happening. Right there. You need to be at 50 feet before you have a probability less than the statewide average for a coliform detection, 50 feet. So what does that mean for Kewaunee County? For the number of wells in the county, we estimate that more than half have a greater probability than the statewide average for coliform detection. Does that all make sense? Let's look at nitrate then. Same thing, same plot. Here's depth to bedrock, same axis, 50 to 200 feet. Here's probability again, but now instead of probability of coliform, it's probability of having a nitrate level greater than 10 parts per million. 20%, 40%, 60%. Highly significant. This is for the summer. I'm not showing the other two plots just to make it simple, but we see the same relationships in the other times of the year. Highly significant. Look at here. You got to be again, here's the statewide average, 7% in Wisconsin. Again, just coincidentally, because nitrate behaves very different than coliform bacteria in the environment. Coincidentally, you need to be at 50 feet before you have a probability of having a high nitrate level less than the statewide average. And because it's coincidentally at 50 feet, you get the same number of wells. So more than half the wells in Kewaunee County have a have a higher probability of having a high nitrate level than the statewide average. For those, this is all new. For those of you that have seen it before, when I presented it in the past, it was by categories, 0 to 5 feet, 5 to 20 feet, and greater than 20 feet. And if you remember, I said we can model this as what we call a continuous variable. That is, for every foot of depth to bedrock, we can get the probability of detection for these things. So this is all new data. Let's move on to the source of contamination. Where's it coming from? So From the wells that were positive for total coliform bacteria or had a high nitrate level, from those wells, that subset of wells, wells that we knew that had an issue, we then randomly selected from those, again, stratified by depth of bedrock, selected for those, and then applied these methods, these genetic methods for determining the microorganism in the water, in the source. And we did this 5 times, April, August, and November 2016, and January, March of 2017. Excuse me. Here's how we do it. I'm not going to spend a lot of time on the technical stuff. We did 131 households, 138 samples, 138 minus 131. 7 wells by chance, by random chance, were just selected twice. So 138 samples, 131 wells. We use these hemodialysis filters to concentrate everything, and we're going to use these methods for looking at the genes that are specific to certain microbes. And we're going to have 3 groups of microorganisms. We're going to talk about human-specific, the bugs are only found in people. We're going to talk about bovine-specific, the bugs are only found in cattle. And then a group of microorganisms that we can't tell where they're coming from. Could be in cattle, could be in people, could be in birds, could be in frogs. We don't know where they're coming from. Those are the three groups. So what did we find? So this is the human side, human specific, over here on the left. These are the bugs. If it's in red, it's pathogenic. If it's black, it's a friendly bug. One of that is in all of us. That's what we call a commensal, one that helps our metabolism, helps us digest. So we had 1 well that had an adenovirus A. We had 1 well that had a Cryptosporidium hominis. This is specific to people. This right here, this column on the right, you can think of that as bugs per quart. The jargon is gene copies per liter, but you can think of it as number of microbes per liter, number of microbes per quart. So reasonably high levels. And then this one right here, this human Bacteroides, this is in every human being. It's in all of us right now in our gut tract. We can detect it in groundwater, and when we find it, it tells us there's human fecal material in that water. And then what's new for this data, for those of you that have seen this slide before, we have taken the trouble to what we call subtype, that is, identify the strain of rotavirus. If you remember from past talks, I didn't have this rotavirus A in the human-specific column. That's because we didn't know if it came from a cow or from a human. We've done the extra genetic test so that we can now say it's from a human. So we have 7 rotaviruses that came from people. Overall, 33 wells had evidence for human wastewater in them. How about on the cattle side? Bovine specific. The plot, this table, is organized the same way. Red is pathogenic, black is a friendly microbe. And this bovine Bacteroides, this is the sister of the human one. It's just that it's specific to cows instead of people. So a lot of those, 36 positive wells, 4 and 2 for these sisters that are, again, commensal friendly bugs. 8 wells had bovine polyomavirus. 1 well had bovine enterovirus. Here's that rotavirus A again. Again, this is new data. We did the genetic test to identify this group A rotavirus that's positive to cattle. Sure enough, 12 wells positive for that. Overall, 44 wells positive, evidence for manure in them. So, not to be too lighthearted, this is what the score is in terms of well contamination. 44 for manure, 33 for human, 9 wells were positive for both. And the other jargon is just from the Google image, 3 down, 9 to go. So 44 wells positive for bovine, 33 for human, 9 for both. But you can't say, I don't want you to conclude from this that there's more manure contamination than there is human contamination, because it really depends upon when we sample, and we're going to get into that in shortly. It depends upon the time of year when we sample. But overall, both, we had the slide with cattle manure, and we had the slide with septic systems. Not surprisingly, the poop from both are getting into the groundwater. This is the slide that caused me a lot of angst during this study. These are the other pathogens. We can't say where they're necessarily coming from, but people have heard me say this before. You just can't be drinking water with these. You can't be drinking water with this in them. These microorganisms are not good for you. Campylobacter jejuni, 1 well. Cryptosporidium parvum. This Cryptosporidium you can find it both in people and in cattle. 13 wells. That's really surprising because it's a big microorganism. You don't expect to find it in groundwater. Pathogenic E. coli was there. Counting rotavirus again. Rotavirus C, this is unusual to find. This is one of the rotaviruses that can go between people and cows. And then this one really concerned me. We had 5 wells positive for Salmonella species. So again, we called homeowners that were positive for these things and let them know that they probably shouldn't be drinking their water. And then this pepper mild mottle virus, this is something we use in my lab similar to the coliform bacteria. It's not pathogenic. It's an indicator to us that human fecal material is reaching the well. Why human fecal material? You never see these peppers. This is a plant virus. It causes the mottling and just really unpalatable appearance on peppers. That's almost a tongue twister. Unpalatable appearance of peppers. But so being, they're not sold in grocery stores. Instead, they're made into salsa. And then you eat the salsa, it comes out the other end, and then we find it in the groundwater. So that's the way that works. After the Super Bowl, you can't believe how much of that virus is in wastewater. So that's how we use that. But overall, in total, 79 wells, 79 out of 131 had evidence of fecal material in them. That's 60%. 60% of the wells. That's a high number. So what we noticed, going back to this variability, is that it really depended upon what we found, human or bovine, depended upon recharge. And Maureen already explained to you what groundwater recharge is. And this is, I think Maureen already had this plot. Here's on the left axis here is the groundwater level, and this blue line, this is a well, I forget which road it is, KW 183, it's in Kewaunee County. And you can see here's springtime, that's 0, so sure enough, the groundwater level is right at the surface at that point in spring. I drove by some places on the way here today that the groundwater level is at the surface. And then here's summertime approaching, down goes the groundwater level. Here's winter. Now, surprisingly, we're seeing these recharge events in the wintertime. I don't know back in the 80s if you saw those, but it's unusual now to have, it was unusual to have groundwater recharge in the winter, and now we're seeing it more and more. Here's spring recharge again, and then here's when manure is applied in the spring, manure applied in the fall, and maybe some manure applied in here. And so what do we see? Let's look at this first sample up here in the upper left. No recharge, and just before manure is applied. And then this is what surprised us. Almost all the wells that we sampled during this time, it was majority human wastewater contamination. 5 bovine, 11 human. How about during the summertime with manure, maybe some manure being applied here, but with no recharge, it's about 50-50, 6 human, 5 bovine hits. How about here? Manure's on the surface now, it's fall recharge, the leaves are off, groundwater levels are rising. Only 1 well was positive for human, 16 wells positive for manure. And now the manure ban in Kewaunee County is on January 1st. This is shortly after it ended, but recharge is underway, again mostly bovine, and then 3.5 months after the manure ban, but at the peak of spring recharge, we see 9 human, 3 bovine. So what is contaminating the well depends upon groundwater recharge. And so the next 2 slides are a conceptual model of what we think is happening, and then I'm going to get into the statistics and demonstrate that what we thought was happening is happening. So this is what we think is happening in Kewaunee County. So here's the household with the septic system, and then over here is the tractor spreading manure. On the human side, this human pathogen source, it's a small fecal source. People don't defecate as much volume as material as cows do. So it's a small fecal source. It's subsurface release continuously, and it's continuous infiltration. So as long as people are living in this home, flushing the toilet, doing the dishes, taking a shower, that effluent is constantly being released in the environment, and it's being released underground. So from the pathogen's point of view, it's a head start to the groundwater. It's 3 or 4 feet down. You're not starting at the surface. Compare that to manure application. It's a large fecal source, about 150 pounds per day for a milking cow, for a full-size milking cow. It's surface applied periodically, and it's episodic infiltration. Why episodic? Because water's not being applied to here, moving it down unless it rains or there's snow melt. Unlike here, where water's constantly being released. So what that means is that the contamination varies depending upon groundwater recharge. And this is a cartoon that we came up with about halfway through the study, and it turned out to be, for the most part, true. So on this axis, on the y-axis on this side, on the left side, we're just saying contamination high, contamination low. Then over here is depth of groundwater, shallow, deep, winter, spring, summer, fall. This blue line is a cartoon of what we see in nature, where groundwater recharge in the winter tends to be not happening, and then in the spring, here's snow melt, up goes the groundwater level, down it goes in the summer, and then here's the fall recharge. And the manure application in Wisconsin tends to coincide with recharge in the spring and in the fall. And then what we think is happening, and sure enough it was borne out, is that on the human side, it's just this green line, it's just always kind of there. It's continuous. Low level human wastewater contamination is always there because the septic systems are always there, and the septic systems are always releasing this material. Whereas the purple line here, the bovine contamination, the manure contamination, there are times when it's not there at all, it disappears. It peaks in the spring recharge when after manure's been put on, groundwater levels are rising. It probably disappears again in the summer a little bit and then happens again in the fall. And then we're going to look at some statistics here shortly that demonstrate that this is what's happening. But before we get to that, let's just talk about this third objective and how we did this. So this is all new for those of you that have heard this in the past. So what we're going to do now is relate these risk factors to well contamination. And I've got them broken into various categories. So here's contamination source in the upper left, bovine and human. Here's karst features like sinkholes, bedrock features, precipitation in groundwater, and well construction. For the contamination sources, we're going to look at agricultural fields, we're going to look at manure lagoons, we're going to look at septic systems, and we're going to look at fields that have had septage applied to them. And we're going to look at three scales, 750 feet, 1,500 feet, and 3,000 feet from a well. And there's several things we're going to look at here. We're going to look at the distance to that particular attribute, and we're going to look at the count, the number within that area. So three areas, 750 feet, 1,500 feet, 3,000 feet out. We're going to counts of those. And then for the karst features, we're going to do the same thing for counts. And then precipitation, we're not going to count snowfall, we're only going to count rainfall over 2, 7, 14 to 21 days, groundwater recharge, depth of groundwater, and then well construction. These are all the things we're going to look at. Well depth, casing depth, depth of groundwater, depth of bedrock, open interval length, the age of the well, the length of casing into the bedrock, the length of casing below the water table, the elevation of the soil drainage. All the characteristics of well construction. How do we do this? So we use geographic information systems. Davina Bones's office gave us the layers, they're called, the maps, and then we used computer programming to extract all of this data. So let's just demonstrate what we're doing here. So this is not a home that we sampled, that's all confidential. This is just one that we pulled from a map. So this is a home in Kewaunee County, located with this blue dot. This is a 3,000 foot radius, which is equivalent to roughly, 3,000 foot radius is equivalent to a square mile. So a square mile. So now what we're going to do is count these features within that square mile. So to begin with, here are the septic systems. I think there's 13. 13. So for this well, we're going to say that well, whether it's contaminated or not, it has 13 septic systems in its 3,000 foot radius, and the distance from the septic system, the closest septic system, the nearest neighbor, is this distance from here to here in feet. Or maybe it's this one, whatever one's closer. Okay, how about manure storage? Oh, there happened to be one here. So for this well, we're going to look at the distance from here to here, and we're going to say there's one manure pit near that well. How about sinkholes? There's 4 of them down here, these purple triangles. 1, 2, 3, 4. We're going to say the distance to the nearest sinkhole, and it's going to be 4 sinkholes for that well. How about septage? Is there any human wastewater, human septage being applied to the fields in this area? Sure enough, for this well, there is. So we're going to calculate the distance from this well to the nearest septage field, and we're going to count the number of acres here for this area. And then lastly, this is just demonstrating how we do this. This isn't all the risk factors that we did. How about agricultural fields? This green, these are all the agricultural fields around this well. Here would be the distance from that well to the agricultural field, and then we would count the number of acres in that area. We did that for every well. So you see how this works? We have the outcome, that is contamination, whether it's total coliform, high nitrate, human, bovine. and then we have an equal sign, and then we have these risk factors, and then we model that. That's how we do it. So we have a dependent variable, contamination, and then these are the independent variables. So this hasn't been done before. This hasn't been done before. So that's how we're going to relate all these. So what did we find? How about for human fecal contamination? If you buy a home in Kewaunee County, get away from your neighbor, because the distance, that turned out to be highly significant. How close you are to your nearest neighbors. We could not relate the home, the well's own septic system. The resolution of the maps wasn't great enough, so we looked at the nearest neighbor. And sure enough, the closer you are to your neighbor's septic system, the more likely you are to be contaminated with the marker. And the number of neighbor septic drain fields around the well, that matters. When it rains, that's a risk factor. Depth of groundwater, depth of bedrock. Surprising, unimportant factors. Well construction. Doesn't matter. And Maureen said the same thing, based on observation. This is statistical evidence that it doesn't matter. You're just as likely to be contaminated whether your casing depth is 200 feet or 40 feet. It doesn't matter. Here's an example. So here's one of those slides again. We're going to see a couple of these now. So now these are two plots, one on top of the other. So here's the y-axis right here. Now we're looking at the probability of a human wastewater detection. Again, 20%, 40%, 60%. But now we're looking at two risk factors. This is groundwater depth. This is the number of drain field septic systems within 750 feet of that well. 750 feet is 40 acres. So how many septic systems are within 40 acres of that well? Not surprisingly, the deeper the depth of groundwater, the lower the probability of being contaminated with a human marker. And then this is surprising. By the time you get up to 10 drain fields, 10 septic systems within 40 acres, you're almost up to a 60% chance of having your well contaminated with human wastewater. That's what this plot's telling you. And remember, these big red lines, that's telling you there's a lot of variability out there. Nonetheless, this is statistically significant. How about for manure? What's important there? Recharge, just like I talked about with that one cartoon, that one slide. Depth of groundwater, depth of bedrock, and then the interactions between ag land use, manure application, and groundwater recharge. What we're wrestling with here statistically is that septic systems don't drive around in the roads. They stay in one place, and the poop is there all the time, being released. The manure applications are moving around, where they're put and when they're put. So we have to account for that, and we have a way of doing that now. So we call that an interaction term. Unimportant factors, again, well construction. Wasn't important for manure. Doesn't matter whether your casing depth is 200 feet or 40 feet. Here's this example. Now, this is now on the y-axis, probability of manure-specific detection. And we're looking here at 7-day cumulative recharge. So we're actually measuring how many feet up the groundwater is going over a 7-day period. And this is when manure is absent. This is when manure is present. When I say manure absent, I'm talking about 3 months after the manure ban, before manure started to be applied on the field, and also early April when we sampled when there had been only like 1 day of manure application. That's what I'm classifying as manure absent. And when you see that, look at this line, it's flat. There's just no relationship between recharge and manure contamination, none whatsoever. It doesn't happen. Not surprising, you don't have the source. You don't have the poop. So there's nothing to contaminate. Whereas for here, when manure is present with recharge, the more recharge you have, the greater the probability of contamination by manure. How about total coliform and nitrate? This is where the agricultural risk factors start to show up. And I think that the reason it is because what we in statistics call our N, our sample number, is very high compared to the other measurements we had. Now we're talking 300, 400 wells. And what we see here is for total coliform and high nitrate, the distance between a well and an agricultural field is important, the number of acres of ag fields around a well, the number of sinkholes around a well, the distance to the nearest manure lagoon, groundwater recharge, and depth to bedrock. All of these are important, that are important risk factors for total coliform and high nitrate. Surprising unimportant risk factors, septic systems. Septic systems for whatever reason, were not related to total coliform and high nitrate, nor again were the well construction variables. So let's look at these ones. Here's again that plot, probability. We're looking at total coliform again here. There's two of the plots, 20%, 40%, 20%, 40%. The green line is the state average. These are marginally or even more so statistically significant. We're looking at 2 times fall. And what this is saying is that you need to be about 500 feet away from an egg field before the probability of a total coliform detect is less than the statewide average. So 500-foot distance. And here, for the number of egg fields within 3,000 feet, 3,000 feet again is about a square mile. The maximum here would be 640 feet. 640 acres is a square mile. So in this situation, you need to be less than about 350 acres around your well of egg fields before you're less than the statewide average for probability of detection for total coliform. Same thing for nitrate. Here's the nitrate plot, probability. Here are the 2 risk factors, egg fields within 3,000 feet, bedrock features at the surface within 3,000 feet. Bedrock features, we're not talking about sinkholes, we're talking about rock, exposed rock or ledges. So for here, and this is the statewide average, you need to be about less than 300 acres of egg fields before you're less than the probability for contamination, for high nitrate. And then here, not surprisingly, the more rock ledges you've got around your well, the more likely you are to have a high nitrate level. And then this is the one that we've been wrestling with. This is relating the distance from a manure lagoon to contamination. And so this is probability of detection for total coliforms and nitrate. Here's the high nitrate plot. Here's the total coliform plot. Here's the statewide averages. So you have to be about, I hate to say it, about a mile away, a mile and a half away from a manure lagoon before you have a low probability of a high nitrate level. And for total coliform right here, you can see the plot. The further away you get it from a manure lagoon, the lower the probability of detection. And then in this situation, you need to be probably closer than 2,500 feet before you have a higher probability than the statewide average. But the way this study is designed is what we call an association study. It's not an experiment. We didn't take a bunch of homes and in some homes build a manure lagoon, and other homes we didn't build a manure lagoon. So we're working from existing data. And with studies like this, you always have to think, oh, we showed this risk factor. There's a statistical correlation, but that doesn't mean it's always right. So in this situation, what it could be, and Maureen and I have talked about this, hydrogeologically, it is entirely feasible that things are moving that far. Hydrogeologically, during groundwater recharge, things could be moving 10,000 feet through one of these fractures. But the other thing that we think about, but we don't have the data necessary to support this, is that in general, and I need to get this information from the dairy producers, is the further away from a manure lagoon, probably the less volume of manure applied. So this might be what we call a confounder, or a surrogate measure for volume of manure applied. So it might be that while this says distance manure lagoon, this might be the same as volume manure applied by distance. See what I'm saying? So we can't separate those two out. That's the shortcoming, that's the limitation of a study like this. We can't do an experiment of building manure lagoons around people's homes. We can't do that. Maybe we could. But so we're left with these association studies, and there's limitations to these studies. Nonetheless, we think this is important information. Now, quickly, Susan asked me to talk about this, so I'm going to digress to a previous study. But the bigger question is, do people get sick from this groundwater contamination, whether it's manure contamination or septic system contamination? And the answer is yes. It's just that it's tough to measure. For the run-of-the-mill illness, what we call sporadic illness, those are tough to measure unless you're doing an epidemiologic study and you're surveying people routinely. But when you have an outbreak, like this one that happened, 10 years ago, 11 years ago in Door County, it's something that then you can study and investigate and understand the source. So if you want to read about this outbreak, Susan asked me to talk about it. It was published in the journal Groundwater in 2011, and we're talking about Door County. This is what happened. I got a phone call. I don't know if Rhonda's in the audience, Rhonda Kohlberg, but Rhonda gave me a call. And they thought there was an outbreak underway near Egg Harbor, a restaurant, as early 2007. Ended up with close to 230 patrons and employees ill. It was a new restaurant, a severe acute gastrointestinal illness, 6 people hospitalized, 1 that nearly died. There are people in this audience that helped with this. Bill Schuster, Chris Olsen's here, Laurel Bratz is here. They were all involved with this study. This was very concerning that this was happening in Door County. We all stood, I can't remember if you and I were standing there, Bill, but a number of us stood at that restaurant and we went, what the heck is going on here? This is a new restaurant, a new well, a new septic system. Which neighbor is doing this? There's got to be a neighbor somewhere. As you know, it's a vulnerable setting. Maureen has already talked about that. And the epi folks, I love working with epidemiologists. I see Dan's in the audience. They always beat me to the punch. Their methods are better than my lab methods for determining the source of contamination. And the epidemiologic data said it's the water. There's something about the water. So what we did is we sampled the water, and we found 50 copies of norovirus in the well. We sampled the septic tank. We had close to 80,000 copies, 80,000 noroviruses in the septic system. And for those people that were sick, we got a stool specimen, and we had close to, what is it here, 100 million per gram of fecal material, 100 million noroviruses. And then what we did is we sequenced, it's not DNA for this virus, it's similar, RNA, but we basically sequenced the DNA, and it matched. So that told us there was a link from to these 3. It was the same identical norovirus in the well, in the people, and in the septic system. So now the question is, how are these hydraulically connected? They're biologically connected, but how's the fluid moving? So what we did is we brought in Calvin Alexander and his team from the University of Minnesota, and they put in a dye, eosin, in the toilet. Here's an aerial view of the restaurant. They put eosin in the toilet. They put another color dye, fluorescein, in the dosing chamber, instantly turned on the pump, and they pumped that up to the drain field here. So 2 different color dyes, one put in at the toilet at the restaurant, another one put into the drain field. And now we're going to see when they show up in the well. And they showed up very quickly. So here's the sample date. This is the concentration here this is concentration of the dye. This is when it rained, these bars. And what you see is that the dye that was put in the toilet showed up in about 6 days in the well. So from the toilet to the well, 6 days, and for the dye that went to the septic system drain field, that was about 15 days. So both dyes showed up, one faster than the other. And that was sufficient evidence then for a forensic investigation where they took the time to dig up the new septic system. And sure enough, when they dug it up, you can see right here, there's this rubber boot connection, and that was torn. And you could see the dye at where that boot was sitting in the soil. So that was one source right there. It was coming out. There was a tear. Something happened during the construction of the septic system. But the other thing to keep in mind, and this is a cutaway, here's the well, here's the drain field. So it took very little time to move from the septic tank to the toilet. That was the eosin, that dye. And then the green dye, the fluorescein, took only 15 days to go from here to here. Dyes move slow compared to bugs. Pathogens move sometimes 10 times as fast. And the reason is they're particles, and they follow the little fractures. So they tend to move faster than something like a dye. But regardless, even if it took the norovirus 15 days to reach here, norovirus survives in groundwater as long as a year. So both sources, the drain field and the torn boot, which contributed more to the contamination of the well, we don't know. But both sources, this drain field contributed to the contamination of the well, and this restaurant now has basically a drinking water treatment plant in the basement to stop this contamination. And what we were able to do, here's the restaurant, here's Green Bay, Egg Harbor's up here. We asked homeowners to put a little piece of charcoal in their toilet tank. Every time they flushed, there was new water in, and that charcoal absorbed the dye if it was getting to their personal well away from the restaurant. And what we could see is that dye that we put into the toilet just kept moving out towards Green Bay. So all these homes in the toilet tank had evidence of the dye. So the point is that these things moved. And we found the virus for a little ways, and then the virus just became attenuated. We no longer saw it. But the dye we saw move all the way to the spring here. So it moved a long distance. And it's always great to get press. It's always good. Local geology is illness factor. Summer flu study is made by scientists. You always feel rewarded, except you find out that this was from the Door County Advocate in 1955. So to reiterate Maureen's point, this has been an issue for a long time. And I mean, I've enjoyed working here. It's a great place, but after a certain point, I think we got enough information to make the decisions. And Susan, I'll here. You have the summary, you know what's going on, and I think we're going to take a break now.
I'm going to ask you to hold your question here. We like you to come here, but we'd like you to come to speak to us, not to have to figure out what bugs we got.
So we take a break?
Sure. Okay, we are going to take, yeah, good idea. Now that you've seen our problem, we're going to talk about some things that have been done and can be continued to be done to allow us to have a safe environment and a safe resource. So we're turning to our local experts. I'm going to introduce them, and then I'm going to allow two at a time to escape into the audience, and they'll come back and speak in turn. They will help you understand how some of the ways that Door County has approached the protection of groundwater. And some of them have brought materials which are in the back if you want them. Grant Thomas graduated from the University of Pittsburgh and Ohio Northern University Claude W. Pettit School of Law. He worked in private practice in Oshkosh before becoming the Assistant Corporation Counsel for Winnebago County. He became Door County's Corporation Counsel in 1997, and he is a past president of the Wisconsin Association of Corporation Counsels. And the only area of concern that I have about Grant is that he still roots for the Pittsburgh Pirates. Right?
Steelers and Penguins too.
Oh, Steelers too. Drat. All right.
Penguins.
Okay, Chris Olsen has served in the Door County Land Use Services Sanitarian Department for nearly 25 years since graduating in Natural Resource Management from UW Stevens Point. Alongside his education and 20-plus years of experience regulating septic systems, he learned the real work is about people and their variable relationships to water. Chris remains active in professional organizations, representing other county staff statewide as chair of the Department of Safety and Professional Services Private On-Site Water Treatment Systems Committee, a member of the DNR's Septic Study Group, and personally involved with other water organizations as president of Lakeshore Natural Resource Partnership Incorporated and board member of Healthy Water of Door County, a subgroup of the Door County Community Foundation. He's also a former board member of the statewide Wisconsin On-Site Water Recycling Association. Erin Hanson has been head of the Door County Soil and Water Conservation Department since March 2017. Her work there focuses on overseeing programs designed to protect groundwater and surface water quality and reduce the impacts from agriculture and stormwater runoff. Erin has 10 years prior work experience with the Wisconsin Department of Natural Resources in Green Bay. While at the DNR, Erin provided oversight for grants to counties and municipalities for non-point control projects and worked with county land conservation departments to implement state agricultural standards. Erin has a master's degree in aquatic biology from the University of New Brunswick and a bachelor's degree in biology from St. Francis Xavier University, both in Eastern Canada. And with that, I will turn it over to Grant.
Good morning. And you will notice the first thing Chris and Erin did was run away from me. As Susie said, my name's Grant Thomas. I've had the privilege of being Door County's Corporation Counsel since 1997, and it's been an absolute joy to work here for the past 21 years. So, and what I'm going to talk about today are three things. The handout that I brought was back on the table. And I refer to these as the three-legged stools, those being regulations, administration, and enforcement. I'm going to go heavy on enforcement because that's what my office is primarily involved on. But I want to touch briefly on the regulations. I should also back up and say this is incredibly unfair for me to have to follow two PhDs. It's like any band that has ever played after the Beatles. So I'm going to try to lower the bar so Erin and Chris have an easier go of it. But what's important about what the good doctor said ties into regulations. Without regulations at the state level and at the local level, all this is for naught. And if the regulations don't match up with the science, what we know the problems are and what we know the solutions are, they aren't any good. In Door County, and this isn't saying it's not the case anywhere else, but I think, at least at the level of the county board, which is what I'm most familiar with, we have exercised as much control as the statutes allow us to exercise. What you need to remember here is counties are creatures of statute. We exist because the state allows us to exist. Any authority, power, regulatory or otherwise we have is only because the state legislature has given it to the county, primarily through the Wisconsin statutes, also through the Wisconsin Administrative Code. And one of the things that I will mention in listening to Maureen and Mark talk, perhaps with respect to the private on-site wastewater treatment systems is the best example. Those systems were installed pursuant to state code. They've probably been maintained pursuant to state code. Yet they aren't doing what they are intended to do by virtue of the end result, that being the groundwater being contaminated. And that's an example, I think as clear as we can get, that if the regulations aren't designed to correct the problem, they don't do a lot of good. Moving on to enforcement, which is, I have about 15 minutes, so I'm going to fly through this. One of the things you will note, I am from the Mid-Atlantic. I get made fun of when I go home because I talk too slow. So you will note I talk fast by Midwest standpoints. But if you don't have an effective enforcement program, again, the regulations and administration of those regulations don't matter much. And the enforcement programs are necessarily bound by the culture and resources of the place where you are at. In terms of the culture, there are varying views on how much government regulation there should be or shouldn't be. With respect to the resources, that comes down to money. If a county or municipality doesn't have the resources, by that I mean staff, attorneys, scientists, code administrators, to effectively regulate, again, they're not going to be able to do a very good job. In Door County, I think it's safe to say that the county board values regulations, values protection of groundwater and surface water and air quality and those sorts of things, and has given staff the tools it needs to do its job. In Door County, again, which is, I'm going to say that 100 times, it's a bad habit, I apologize, is the enforcement measures, or how we approach enforcement issues, pretty much match up with what everybody else does. We are basically a complaint-based code enforcement system. That means that somebody calls in, something comes to our attention, and we react to it. We don't have a systematic code enforcement system across the board. In certain areas we do. Chris will doubtless speak to what's been done with the private on-site wastewater treatment system surveys and how that was a systematic approach taken region by region throughout the county. We also engage in code enforcement through what I call windshield surveys, and that's county staff driving around and noticing violations, and then that prompts an investigation. So once a potential complaint or a potential violation comes to our attention, what do we do? From a code enforcement standpoint, we need boots on the ground. We need a code administrator to go out, inspect, conduct testing, do an investigation, and determine whether or not a violation exists. If a violation is found to exist, we move on to enforcement. Now, sometimes, understandably so, people aren't all that thrilled about a code administrator coming onto their property. In that case, we have some tools in our tool belt. What we use mostly are special inspection warrants. That only happens in a small majority of the cases. Most of the time, people are more than cooperative with our efforts. But if a violation is found to exist, then you have to take a look at what approach do you take to make sure that the violation is corrected. And we take a measured approach in most cases. And by a measured approach, I mean we alert the person, be it the homeowner or the person that is causing the violation, to the nature of the violation and the remedial measures that are necessary to correct the violation. And generally, if it's not an imminent risk to health or public safety, they are given a reasonable period of time to correct that violation. For instance, with the private on-site wastewater treatment systems, I think it's safe to say we give people typically about a year from the point in time where a violation is identified until it needs to be corrected. That's in recognition of the fact that we live in Wisconsin, the construction season is relatively short, and some of these systems, new replacement system, can run into tens of thousands of dollars. So it's not a trivial thing for somebody to have to replace their septic system, and we understand that. One of the things that we also try to do is communicate with the people in person if at all possible. And that's one thing that everybody that has ever worked with me, be it in planning and zoning, in our sanitarians department, our soil and water conservation department, or otherwise, if you identify a violation, we don't want the people who are being alleged to have violated code to hear about it in a letter, necessarily in a voicemail, in an email. If at all possible, you want that face-to-face communication to humanize it. Knock on the door and in a non-confrontational way, identify the problem and try to engage in a dialogue. Again, the vast majority of the time, that works. When it doesn't, we have to move on to more enforcement type measures, more significant enforcement type measures. And I can't stress enough that with code enforcement and regulation, community buy-in is important. And if we go about enforcement in the wrong way, we're going to create a hostile environment in the public, and that doesn't serve anybody's interest. So that's a segue to our next topic, is what do we do when we give notice, give people a reasonable amount of time to comply, and they still don't comply? Then we get into the formal code enforcement aspect of our work. And that's probably 1/2 of 1% or 1% of the cases that are identified. I can say, I think without any doubt, that 99% of the cases where a violation is identified, they are voluntarily resolved. So what I'm talking about now is the 1% and probably less of the cases that we deal with in the county where that doesn't happen. The first thing we do, again, is a measured approach, is we issue a citation. A citation results in a monetary penalty only, not injunctive relief. And a person is fined, usually for 1 day of violation, and that's typically enough to get most of those people in the 1% to say, hey, this is serious. Rather than pay the court, we're going to devote our time and resources to correcting the violation. And then we have the 1/2 of 1% or less who aren't convinced by a citation. Our formal referral is made to my office, and we do what we call a big claims summons and complaint, which is a civil action. In that, we file a summons and complaint. We request not only monetary relief, but injunctive relief, where if the county's successful, the court is ordering somebody to do something. And if a court orders somebody to do something, one, it ups the ante with respect to the monetary violation, because under Wisconsin law, you are going to be fined each day that the violation continues, at least the minimum amount of the fine that's provided for in the code. Over a course of a year, even a $10 a day fine can add up pretty quickly. Second aspect of that is because the court is directing somebody to do something, it opens the door to an injunctive order, and if the person doesn't follow that order, contempt proceedings. Contempt proceedings are where we go into court and say, Judge whoever, this person was ordered to do something, they were given a time frame within which to do it, they haven't done it. Judges don't take very kindly to that, and they will enter a judgment in remedial contempt, which can include additional fines, and in other cases, even incarceration, provide the person who has not complied with the court order what they call an opportunity to remove the contempt by meeting the conditions that are established. Now, if they don't do that, the next step is punitive contempt sanctions, which often include a little bit of time in the county jail. That has happened maybe in 6 cases in the 21 years I've been doing that, and in most of those cases it was just a situation where somebody didn't want to do what they were ordered to do. So I've kind of ran through what enforcement looks like, and I don't want to, again, leave the impression that court is involved all that frequently. It's not. It's less than 1% or less. And I think that's because we've sort of framed the debate in Door County well over the 2 or 3 decades that we've been actively involved in this. And by that, our first step has been to educate people. Educate people on what the problem is, educate people on why the regulations exist, and also try to convince people it's in their own enlightened self-interest and also in the interest of the community to comply with the regulations. You want to paint the enforcement measures in a positive light and focus on compliance. And you want to get to the point where the 99% that are in compliance are saying, yeah, I understand, it's not a pretty sight when somebody's hauled into court on a zoning violation or sanitary violation or any other violation and is faced with an order where they're compelled to do something they really don't want to do. But from the community standpoint as a whole, we have decided that, again, using the example of groundwater or surface water is important, and activities that do harm to that need to be stopped. So with that, I think I will turn to Chris, and I think we're taking questions after this. Thanks.
Yeah, I think I pulled up the wrong thing there. Sorry, I didn't know it was going to be you.
No worries.
We'll just escape and do the other one. That's you.
Yeah. I wish I was going last because I feel like I deal with one of the most remedial jobs and or practices that exist out there. So today, who's used a toilet? Can you raise your hand? All right, and then a group exercise I like is that on 3, can you snap your fingers? 1, 2, 3. Okay, now it's really hard. Like I said, I'd rather go last because following the rock stars, the Beatles, et cetera, like I feel I'm dealing with something I'm going to talk about. Really, I don't even know if I can make it entertaining. So let's see. You know, we talk about what this really reminds me of listening to everybody today, and even being in this room with some notables and rock stars, is that this is all like it's a building bridges, and I'm, as my family and friends call me, a poop cop. So we have scientists that have really done really specific stuff, and there are policymakers that enact things in response to that science. And then I'm a poop cop, so I enforce it to another group of people that are lay people that flush the toilet. You live in the country and flush a toilet. I've been paid for 25 years to care. And I do, trust me. I wouldn't be here today if I didn't. So getting back to is that I like this quote, and maybe just to start, and even just thinking about like holy, we're on camera, spit, being reminded of this science and what happens and how things are really happening well below ground. Part of my job is to bring that science out of the ground from the policymakers to people above ground, but things are moving incredibly fast, and we live in an incredibly sensitive, beautiful place. But we'll talk a little bit about that and how we're reminded of that every so often, and most specifically today. But I like this, that the difference between water and wastewater is the second it takes to travel from the faucet to the drain in our sinks. Can you hear me okay too? All right. So literally, I could probably just show this slide and the last one and drop the mic and walk away following these two and what they've said. So, you know, the really hard part is that following the science and bringing it to people. And, you know, you talk about travel times and throwing numbers and such. And for lay people, they think like this can't happen, or we don't see these studies or sciences and stuff. And to correlate or relate that is, I guess, part of my job. So I try to remind people that everything that leaves the tap will go to your toilet, and everything that leaves the toilet will go to your tap. It's not if, but when. It's going to happen. And people are like, what do you mean, flush the toilet? We can't drink our water and all this stuff. And it's just like, it's about time. And for me, it's like soil and glaciers and Silurian Sea. And, in dealing with people, it's like, it's out of sight, out of mind. And this, Jerry's a friend of mine who's now since moved to Florida. But, that for a lot of people, they don't consider what this is or what this means. I mean, this is the choir, this group of people here today that care about water, listening to great people. But we're having to deal with a majority of the population that it's out of sight, out of mind. And, after we left the woods, we went to these privies. Nowadays, we went to a septic tank. And, then going to the drain fields, as we talked about, it's all about soil depth. So we're trying to expand or create more time because things, except for the geology part, we want to extend to treat wastewater, or to think that we are. During the break, I drew a bullseye on my name tag because following these two, I'm kind of a target as well. But I hope I'm still a minion in the process trying to make things better. So in the county here in northeast Wisconsin, we have a lot of variability. I talk to other people in the state and they think I'm kind of crazy. And I'm like, no, things are really sensitive here and they can't relate. So even in this county, we've got some deep soil and some very little. For my purposes with drain fields, we have a state code and it says we need 2 or 3 feet of vertical separation from where the wastewater gets discharged into the soil to a limiting condition like a water table or bedrock. And this is based on other science and scientists in the wastewater world as well. This is a typical side view of a mound. So Wisconsin was one of the first states in the nation to kind of adopt this mound procedure, and maybe a lot to do with the soils we have here. We also kind of originated the sand filter, which is kind of fallen out of sorts with resources. But then we have conventional systems in ground, as is brought up before, and in the last 10 years, half of the systems are conventional systems, which mean they have about 4 feet of soil below the drain field, which, as we found out, is still not enough. Every system today has an effluent filter that has a drain field, and it gets rid of things that are greater than an 1/8 inch, which on science scales is huge. So big stuff. There's some fancy pre-treatment devices out there that basically blow air bubbles into the wastewater, because wastewater aerobic bugs work a lot more efficient than anaerobic bugs. So we give them oxygen, they're a lot more efficient, they like eating each other, etc. There are some crazy people out there. I think there was only one in Northern Door that actually had a closed loop system. They had a constructed wetland in their greenhouse in the house. He's since passed on, and they put a standard system in. Now again, when I talked about talking to other peers, even in my own trade, I go to other county shows or other side of the state, and they're like, oh, Chris, we'll be putting systems on parking lots and all this stuff, and I'm like, I don't think that's going to work in our jurisdiction or zip code. And as I think Mark had mentioned, there are a lot of other things going on in wastewater than just human waste. I mean, all kinds of stuff go down the drain that shouldn't. The big thing now is, and has been for a couple of decades, but like pills and medications and all kinds of body stuff that is not being retained. You take pills, but you're only retaining 20% of the medication, 80% is getting flushed through. And I'm being remedial at saying that, so we have scientists in the room. I'm sure it can get clarified. Like I said, we're putting a lot of things out there that septic systems originally were not designed for. Soil does not know how to necessarily deal with caffeine or aspartame or DEET. There's all these things that are going out there that we're delivering. So to talk a little bit about some of our programs outside of the regulation part is in 1986, June of 86, we started a time of sale program. And that meant that when somebody was going to sell or buy property, they had to have their septic system inspected. I could spend an hour talking about the evolution of that. Plumber getting a video camera and a television station to say this is a violation, you can't come in our property and all this stuff. Lo and behold, though, a few decades later, it was enacted and successful. Just kind of giving some idea that and this is just a bunch of numbers, so this might be a little easier graphs, is that in the course of a year, you can see in 86 on the left of 2015, we've had about the same number of evaluations, and that's property selling, et cetera. The more interesting part, though, is how, as time went on, the number of passing systems increased and the number of failing systems decreased. So that kind of means, for our purposes, it was a successful endeavor. This is just another graph showing the same thing, a good inverse relationship. That not being enough, though, in 2002, it was brought about that we need to be more aggressive. This time of sale stuff, we can't wait for properties to transfer. We got to make sure that people's systems get upgraded sooner than that. So it was developed in a lot of assistance with the Soil and Water Department to come up with some criteria for how are we going to do this. So we're going to say everybody's given a number. Your number is going to be based on depth of bedrock, depth of groundwater, soil attenuation rates, and septic system suitability. So you can see that where we live, things are not contiguous. So your neighbor could be right next door at 341, and you're being done years before that at number 47. So you know, being the cop, the poop cop, I'm having to face these people and tell them why their neighbor across the street this is not their year. Or that they're going to be done they have 10 years to save money. You don't. So like I said, where we live, it's really variable soils, and we started at the lower number is more sensitive, the higher the number, least sensitive. And so we've been spread out throughout the county. This is after about 80% of them were completed, and you can see things are starting to fill in. Since 2015, we actually finished it. So it was about a 12, 13-year cycle, and we can see that about a third of those systems failed. And that fortunately, I mean, we looked at a lot of systems and found the really old systems that we don't have any soils data on should be the focus. Somebody not cleaning their filter or something or other is not a big deal, so we let the new systems off the hook, and that's why the numbers went down the last few years. We only focused on those that we needed soils information on. Again, the only highlight to this is that the last year was the only time we had more passing systems than failing systems. Just this kind of, I wanted to highlight that we've been doing surveys. I started in 94, and we've been doing sanitary surveys or looking at septic systems in the 80s. The state code was adopted in the 60s, so wastewater has always been a hot topic in Door County. And so I'm kind of giving an example of what it's like to look at an existing system, because that's where really the rubber meets the road if things are not good, and I'm delivering the message that if they don't listen to me, they have to talk to Grant, they pay a ticket, and still have to replace their septic system. So this is what it's like looking at a concrete tank. This is what it's like when a steel tank. So we order all these out. There are a couple that passed, but this happened to be a nice county board chairman at the time who replaced his steel tank, and if anybody knows the line there, they may know who that person is. Getting to the real crux is not necessarily always about the tanks or steel stuff, but about soil. And for our, you know, the way the wastewater world works in Wisconsin anyways is all about treatment and what the code says you need for treatment. So it's all about this vertical separation between the bottom of the drain field where the wastewater gets released into the soil and then the depth of the limiting condition like a water table or bedrock. And again, everybody, no stone was left unturned. I guess pun intended that there's stone in this, but another county board chairman at the time was affected or impacted by this process. And even some very rich people. This guy was more happy to put a new septic system in than pay his ex-wife money. And he probably spent more on his lawn than he will on that $10,000 septic system. It goes that, as Grant mentioned, there's a few 1%ers. And I don't know if it's fortune that have been around to witness a couple of those events. And so we have to bring the sheriff's department out, get an inspection warrant. And this person didn't have much of a prayer. Rest in peace, Francis. That 6 inches to bedrock, he didn't stand a chance. Someone went so far as to not agree with the cops when they showed up and was arrested. And I talked to family about that, and it's a poop cop, and like people get arrested over it. It's interesting. Flushing the toilet. Also not immune is I found a deal that a property really cheap. This is my house. And you can see in the foreground there, I've got a steel holding tank that I'm having replaced with a mound system next week. Getting back to our program, we basically, as Grant mentioned, give people a year. And that's variable if people are happy about that, sad about it. It's all about money, and we do the best we can to work with them when if they have to go to Grant's office for that. But people are given a year. There's a couple of funding mechanisms out there. This Wisconsin fund, which is going away in a couple years. This housing rehab loan grant, you got to be really poor to get any money from them, is still available to people. Wanted to highlight that a lot of the rules in for this stuff, it's kind of a trickle down. As mentioned, we're all walking or building bridges. One of our bridges from Wisconsin goes to the EPA. Then we get on a smaller level, there's 72 counties in the state, and we have this umbrella of a policy to try to integrate and get the science to the lay people and hope that we're able to drink the water, just not here. But what that means is, like I said, I go to trade shows and we have this uniform statewide code policy, but it's still not enough. It's not, and we have 72 different opinions about that. So it's all about having shared values and, how do we manage this process and be diplomatic? And a lot of it, I think, is through networking, through other people coming out on Saturdays. It's integrating that into our lives. We live in a place where we have $1 million properties, and this might get a little graphic, and other people that are still going in a bucket. So I didn't need to show it that long, right? You got the picture, maybe? Just that kind of variability. So dealing with those kind of people is variable as well. Also is that everything's not perfect. So we have a new holding tank here. It's leaking the first day it gets installed. This one here is a brand new drain field that got run over by a landscaper, and it's junk. Mark touched on this, but and I think it's bittersweet in a way, but it makes life easier to communicate with people and a community to realize every so often we have an event that brings our immediate attention that we didn't do anything to stop it. And so a few years ago, about a decade, that we had this little virus impact our community, and it made, I think, a legend in some ways. I really liked it in dealing with Mark. He reminded me that, and I'm sure I'm wrong with this, but he would say a tablespoon of this virus contains as many stars as in the Milky Way. And I don't know if that's still accurate, but it was something, that kind of reference, and I'm like, holy spit. And all over what may have been, it was more than that, but it could have been as little as this, and I have it in my office, an $11 rubber fern coat with a tear in it. 200 plus people getting sick. That's an anomaly, and Mark's talked about this before too, that that kind of stuff happens maybe on a cruise ship, but in a community with soil and water, it makes the radar. Also making the radar is that, it's about being safe and rules and regulations. People hate it, but once a year, some kid dies falling in a tank. And that's sickening to me, and I don't even have kids. So it's important that we do the most remedial things. I mean, I'm here today talking about human spit, and yet a $7 lock could keep a child alive? Are you kidding me? So it's about working together and building these relationships, whether it's showing up today or even talking to people as you go away from here, because I will not stop talking about their research and bring it with me everywhere I go. Because it's about protecting the people that are we're most accountable to. And making a decision is not always an easy thing. Thanks for your time.
Thanks everybody for being here today. I'm Erin Hanson, and I did bring some of these brochures, and they're at the back table. There's also a brochure about water sampling if you want to get your well tested after today, or maybe at a time when groundwater is recharging. There's information about where you can take a water sample to get your private well tested. So Chris talked about the human side of things, and I thought it was only fitting that I focus on the agricultural side of things. So we heard from Mark and Maureen about why it's so important for us to think about what we're spreading on the land surface so that we can take action that we have available to us to try and prevent groundwater quality from being impacted. And so today I'll talk about agricultural performance standards. And Door County is really fortunate in having a strong program in this area, and it's to the credit of the conservationists who have worked in this department for years, working with landowners to install practices, and to people like all of you who support protecting water quality. And so with all of that backdrop, I think it's, the next things I'll talk about are the current rules that apply to all farms, whether they be small or large. There are standards that apply to all farms, and how Door County has taken a strategic approach towards implementing those standards, and a timeline for some rules that are coming that are specifically intended to address the unique and fragile nature of Door County. Oh boy.
Not happy?
Oh, that was the wrong way. Nope.
The one on the right advances you. So slideshow, okay, so on the, click on the right.
There we go. Should have figured that out sooner. Here we are. So if you think about agriculture, it can be broken into two categories. There can be livestock sites where animals are concentrated in one area, say at a farmstead, and then there's cropland. And as Grant said, there's uniform standards that apply across the state. And in the case of agriculture, the standards can be broken down into those two categories, into livestock sites and also the cropland. So the standards that we have, without going into great detail about what each of these mean, essentially they're designed to protect water quality by containing the waste that's generated at a farm, manure and other types of waste, containing it and allowing it to be stored appropriately until it can be spread on agricultural fields and provide nutrients. So there's common sense things about making sure that manure storages are designed appropriately and that they're functioning and not allowed to overflow. In the photo here, you can see that there's a unconfined manure pile. And if you think about it, there's a roof here where when it rains, the water can run off the roof, hit the unconfined manure pile, and either runoff can leave the site directly and hit surface water, or if it's a sensitive area, it can infiltrate into the ground. So what's the solution? Let's contain it. Let's build a structure. And here, at this site, there was also concerns about where the animals were eating. That was an open feedlot. So in this case, one of the solutions can be to build a roof and keep the animals under a roof, contain the manure in an appropriate, until it's the right time for it to be spread on the landscape. We heard about there's certain times when it's appropriate to have manure spread on the landscape. There's other times, such as the winter, when the crop can't take up the nutrients that that the manure is providing, and that's when we look to the manure storage to hold the manure. Cropland performance standards. These are all about allowing for the manure to be spread in the right place at the right time, at the right rate, and identifying ways that measures that can be taken to keep the manure where it's intended to be, to provide that fertilizer for the growing crop, to meet the crop needs. Nutrient management planning is a large part of this. And so through a nutrient management plan, a farm can look at the measures that it can take through tillage or reduced tillage or no tillage, other things that can be done to help keep the soil in place, to improve soil health so that there is less risk of runoff from that site. Here in this photo, you can see that there's manure that's been applied to a field that's directly adjacent to a sinkhole, and we consider those direct conduits to groundwater. By having a nutrient management plan and being careful and deliberate about where nutrients are applied and following appropriate setbacks from these conduits to groundwater, there's a way to minimize the risk that that manure would enter into the groundwater. So nutrient management planning is a big emphasis in our department. This map shows statewide the progress that counties have made at getting cropland acres covered under nutrient management plans. And it's a little dark, but essentially what you can see is that in northeast part of the state, there is good nutrient management plan coverage. Door County, we have 88% of our cropland covered by nutrient management plans, and each year the county receives funds from the state that we can then in turn offer to farms to develop a nutrient management plan. And that's one thing that I should have touched on earlier. For the small and the medium-sized farms that were in existence at the time that these standards came into being, we are required to offer cost share to help those farms install practices or develop a nutrient management plan so that they can meet these standards. And every year we get some funding and we work with the producers to develop, to get them into nutrient management, doing nutrient management planning, and we will see that number continue to grow over time. So knowing that we have good nutrient management plan coverage across the state, and knowing that we have a fragile system here, we know based on the results of the science that what we have for nutrient management planning isn't sufficient to be protecting the water quality. Here you can see a map that shows the current compliance status for those standards that I was talking about before. So in Door County, we did take a systematic approach, much like Chris described for the septic systems. In the same way, we did a geographic prioritization, the Soil and Water Department did, looking at different factors that were important for protecting water, surface water or groundwater, depth to bedrock, whether or not the parcel was in a closed depression, the potential of the soil to filter out those contaminants, whether it was a priority watershed, and if there was surface water nearby. All of those came into a formula that was used to calculate that ranking from highest potential to impact water to the lowest. And then the Soil and Water Department worked their way through those parcels, starting with the most, the top ranked parcels, because that gave staff the opportunity to have the greatest impact. So looking here, you can see in the time since then, there's been good progress at turning those parcels, inventorying them and turning them green. And I jotted down we have 340 livestock parcels that would be reflected in this map. 225 have been inventoried and compliance determined. And the one thing that's important to remember is that some are partially compliant and others are non-compliant, and we've identified that, and we're seeking the cost share to help those producers or the landowners install practices to bring them into compliance with those standards. We're reliant on grants to get funding to be able to do that, and we actively seek those grant fundings. So overall, we've made good progress, but just because something's turned green doesn't mean it stays green forever. And you know, it's important to remember that the landscape isn't static, that things can change over time, and this is a snapshot in time. And it's one of the things that we do factor into this is that remembering that just because you're there one day doesn't mean that something doesn't change over time. So that repeated contact and working with people, as Chris was describing, is important as operations change or expand or older practices need to be maintained. We need to keep our focus on working with these standards. So knowing that we have very good compliance with the current performance standards, and knowing that we're seeing that contamination rate that you've described earlier, that you've heard described earlier, the state came to the realization that the uniform standards that were being applied across the state are not sufficient to protect groundwater quality in this part of the state. So in areas where we have that Silurian dolomite with very thin layer of soil over top, the state has proposed some new standards that will provide even greater protection to groundwater. Specifically, they're designed to address pathogen contamination. So they're called targeted performance standards. if you think about, as Grant was describing, we implement the codes that are available to us through statewide. And the code as is written right now applies to the whole state. In cases where it's demonstrated that we can't meet those water quality goals that we have, there's an ability for the state to identify a targeted standard. And just to give you a sense of where we're at in the process right now, and it's been almost 2 years ago since it was determined that they would go through this process. They convened a technical advisory committee that had representatives from various stakeholder groups, from environmental groups, from crop consultants, from landowners and farmers, from county conservation departments. There's some of the people who were on the technical advisory committee may well be here today. But essentially, what came of it was that they took the recommendations, identified some targeted specific standards that could be applied to reduce the risk of manure spreading by prohibiting manure applications on 0 to 2 feet of soil over bedrock, and then providing some flexibility in that 3 to 5 foot zone of different practices that could be employed by farms to be able to spread in that area. So where we're at right now, if you fast forward down to 2018, the proposed rules have been through a public hearing and comment period. They're at the legislature right now. They've been assigned to a committee that it appears that the work of that committee, or the time period that they have for review, will end fairly soon. And then if all goes as expected, they would be promulgated by the Department of Natural Resources in 2018. That establishes standards for a specific area. And then what that means is the county has always adopted those standards into our work that we do with working with landowners. And so going forward, that will be something that we will be working with, have another tool to use to protect groundwater in this area. So with that, I think I'll leave it. I know Susie had offered that there would be opportunity for questions for many.
Okay, thank you. Thank you all. Before we begin the question period, I'd like to introduce our representative to the State Assembly, Joel Kitchens, and thank him for coming this morning. As many of you know, the targeted standards, he's worked hard with Door and Kewaunee County on getting some of those changed, in particular to our area. And I just want to give him a chance to update us on exactly where that rewrite is. You need to talk in here.
Well, thank you. Yeah, I'll just give you a very brief update on what's going on the state level to protect our groundwater and to assure that everyone does have access to clean water. I think it became apparent today, it's a very complicated problem, and it's something that we can't write just one bill on the state level that's going to solve this problem. So it needs to be attacked from a bunch of different angles, both on the state and the local level. And I will say Door County over the years has enforced their regulations much more strictly than any other county in the state. So they've done a very good job of that. But you know, one of the areas is to the immediate concern of making sure that everyone has clean water right now if they have a contaminated well. So at the state level, we've done legislation to help people that have contaminated wells to put in treatment systems or replace the well if that's appropriate. In Kewaunee County, they provided clean water to people that have contaminated wells there. We did legislation to help people that have failing septic systems, to give a tool to help them to put their septic system into compliance, to help that part. The most significant thing, though, that I think is happening right now is the changes to the rules to NR 151, which Erin addressed. You know, it has become very apparent over the years that the rules that we have in place right now are not adequate to protect the groundwater in our area. Bill Schuster, and I think Bill must have left, but he spent his entire career advocating for specific rules for our area, rather than just the statewide rules. I think legislative days from Door and Kewanee over the past several years. That's been one of their top asks when they've gone to Madison. So finally 2 years ago, nearly 2 years ago, the DNR decided to do that. They had been resisting that for quite some time. So the process is underway right now. I think, again, Erin went through the process. Where it stands right now is that it's in the legislative stage, and I think the end of next week, that time will expire. It's a slow process. We've done it in less than 2 years, though. Normally it takes 3 to 4 years to change an administrative rule, but they've gone as fast as they possibly can. But there are statutory requirements that you have to give so much time for groups to comment and that type of thing. So at the end of next week, that'll expire, then it'll be signed and become law, presumably. I think a big reason we were able to get this done is because we did get buy-in from the groups, both the conservation groups as well as the agricultural groups. And it's one of those rare times where all of the major conservation groups around the state, the conservation voters, Clean Wisconsin, have endorsed these new rules, as well as the agriculture groups, the Farm Bureau, Dairy Business Association. And I do give credit for some of the progressive farmers in Kewanee County in particular for really putting their support behind these new rules. Because if there'd been opposition, I don't think it would have flown through as easily as it has. So that is a big step forward. Now, is there more to be done? Absolutely. But again, this is something we've been working on for quite some time, and it's about to happen. I think it became apparent today with Mark's presentation that it's certainly possible that the rules that we have for septic systems right now are not adequate to protect our groundwater, that I think we can have compliant systems that are still causing a problem. So I think that's something we need to be looking at, and I'd be curious what Chris has. I think Chris touched on it a little bit, but I'd be curious what he thinks about that, because that'll be another area for us to look at. So anyway, that's sort of where things stand from the state level, and again, we'll keep working on it. Thanks.
All right, I would like to invite my panels, all my speakers, to come back up here. We had a little technical glitch this morning, and so the way we do these questions is going to have to be, we'll be able to pass this microphone between our panelists, depending on who's going to answer the question. But I will ask, and I'll come around, if you have a question, say it as loud as you can, and then we're going to ask, I'll repeat it into the microphone so that everybody hears it and it gets on the videotape, and then whoever is appropriate to answer it will have that opportunity. So, what do you want to know? Yes, ma'am.
I'm a certified sustainable building advisor, and after listening to Mark and Chris talking about spit, and everyone wonders, what can you do yourself in your own household right now? When your toilet breaks and it doesn't flush anymore, you replace it with a dual flush, low flow toilet.
Okay, I'm not going to remember all that, but keep going.
So, what I'd like to know is there any possibility for the county to possibly change some regulations as far as toilets and low flow water fixtures and water sense low flow plumbing fixtures to help cut down on the amount of water going into septic systems?
Okay. She's asking, is there something the county can do in terms of regulations or something to deal with current codes for lower flowing toilets so that less water gets flushed down? I don't know which of you that wants this.
That's Chris.
I'd say it's a stretch. Just to be honest about it, changing codes, as even Joel had alluded to, is even in the septic world are undergoing things constantly, and it's an exhaustingly, painfully slow process. It just is hard changing people's minds. So even getting to the word low flow is like an anomaly talking to somebody on the street most of the time. Some of us in the wastewater world used to say that the solution to pollution is dilution, so actually getting less water does not make it better. But that's more for science people to say that. Like the bugs in our bodies or the bad stuff that's out there, let's hope it didn't start in the water, that it's actually from us. So less water may not mean less problems.
Grant, did you want to add to that?
I think Chris covered it.
Would you speak a little bit about what Door County did with regard to Erin's, the rules and regs and so on?
Yeah. Susie asked me to kind of delve down into a little bit of detail about what Door County has done and perhaps juxtapose that with what other counties have done. And a good example is in the agricultural standards and prohibitions. Years ago, even before I started there, the county had adopted the state regulations as part of the county code that then allowed us to enforce the regulations a little bit more simply at the county level. And that has continued through today as the state statutes and the state administrative code change in that area. We actually adopt those changes right into our county code. And again, that goes to what I talked about, a culture within a particular geographic or political region in terms of what's important and what in our case, the county board was willing to devote in terms of political capital and also resources, again, money and staff, to make sure that the regulations that we have the ability to enforce are enforced.
Anyone else? Lynn?
Mark, looking at your slides on the pathogen levels, I think I saw that on the human side, it was slightly over 2,000, the highest number. And then on the bovine side, I think I saw 40,000. Is there a difference in potential there between the human side and the bovine side?
You want to paraphrase that question?
To paraphrase the question from Lynn, I believe it is, does the concentration differ between the human contaminants or the human pathogens versus the manure-borne pathogens, right? And the way I had that data summarized is that the maximums do differ. If you take a look at the means, or another summary measure, the median, that is 50% above, 50% below, they don't differ that much. The maxes do differ, the maximums do differ, and in general, the bovine's a little bit higher. But it would be, one of the things I didn't report was the relationship of concentration to those risk factors. So we're doing that as well, just so you're aware. It's just that Susan didn't give me 4.5 hours to speak.
Anybody else? John?
Erin addressed a little bit the NR 151 standards, as did Joel, but I had a question for Mark and Maureen about the new NR 151 standards, which have yet to finish going through the legislative committee review and be signed. And that question is simply that those new regulations say there will be no mechanical application at 0 to 2 feet, and then have standards for 2 to 5, 5 to 20, and greater than 20 is no holds barred in terms of topsoil over bedrock. Do you, I'm sure, are quite aware of those new NR 151 standards, do you believe that they will do anything significant in attenuating the pathogens that are entering the groundwater in Door County?
Okay, so I'll summarize the question. So what he's asking about is the specific prohibitions in NR 151, how much is it going to help? I was actually on the technical advisory committee for NR 151, and I presented some of the county data that at that point we hadn't done the continuous analysis that Mark has since completed, but it was pretty clear that you needed at least 20 to start to really knock down the pathogen numbers. If you do that, we just can't farm northeast Wisconsin. It wasn't going to be viable, right? I mean, all of Door County, you could have no farms. So that's just not real, right? I mean, we worked the landscape in northeast Wisconsin. This was sort of basically what people could agree to, that 2 was, it still left some land in Door that you could farm. It left adequate amounts of Kiwani. I think anything you do that reduces the pathogen load and increases the thickness that it has to get through. I mean, right now, you can spread on 2 inches of soil. 2 feet's better than that. Right? I mean, you got to take what you can get, right? So I think it will help. Will it guarantee? pathogen-free water in northeast Wisconsin? No.
I could just add to that quickly. The data is sound. The relationships are sound. And the stats are there to support that at 20 feet, you're still going to be above the statewide average for probability of contamination. So that's just the case. But you have to keep in mind that we did this study from 2015 to March 2017, and using technical jargon, there's a source term. That is, there was this amount of manure applied to the landscape at that time. If you double that, you half it, that slope, that line changes. So while the code may specify certain depths, 20 feet for example, and amounts, you could change the source term. You could reduce the amount, you could reduce it through various means. So there's other ways of changing that line.
Sorry, we tangled it around. Erin, did you want to add to that? Comment on that?
I think that I would agree with, of course, what you have to say there, and the intent of the rules with the 2 to 5 feet is to provide other options in terms of the rate that can be applied at a given time, and looking at other methods such as pre-tillage to reduce the risk that the manure would travel through the soil and provide opportunity for using cover crops or other methods such as composting to reduce the risk of pathogen contamination in that area. So it's not just the depth of soil, there's other factors built into it too.
Thank you. In the back?
Thanks. This question's for Mark. I can't recall if you mentioned, but what prompted the study that the DNR conducted, you mentioned in your presentation?
I didn't hear the last part.
What prompted the study?
Why did the DNR do
That
this?
the DNR conducted that you mentioned in your presentation.
What prompted the study?
Yes.
You want the politically correct answer or the right answer?
I want yes, all of it.
Mr. Kitchens is here. The correct answer? I got tired of reading in the newspaper from certain people in power down in Madison that there was no technology to say where the source of contamination was from. I read about that 4 or 5 times. I thought, we got to do something about this. This is crazy. That technology's been in place for 20 years. My lab does it. I called Mo. We call her Mo. It was a nice May day in 2014. So let's go sample some wells. So we went to County County. Mo had arranged some 10 homes. We knew it was biased. These were homes that had problems. These were people that had a certain point of view. Nonetheless, we wanted to see what was there. And we were shocked. Shocked at the level of contamination. And that is what prompted us then to write the proposal to get this funded. So that's how it was all started.
Who else? Gentleman in the red sweatshirt?
Excuse me, in 2016, we dumped 43 million gallons of milk in the United States. In 2017, it appears we dumped 72 million gallons of milk. Just threw it away. We have 1.2 billion pounds of cheese in storage with the government with no immediate use for it. Why in the world are we expanding dairy herds in northeast Wisconsin when we have these thin soils, pollution problems, karst rock? Why is the DNR approving every single application that comes along for expansion of capitals?
Well, I would open that to anybody here. I'm not sure we can answer that.
Yeah, we're not regulators, we're not policymakers, we're not politicians, we're scientists. We just produce data. You want to answer?
I said it before, we are creatures of statutes. The county exists within the regulatory framework that they exist. And I thought about commenting from one of Mark's statements and Mo's, and I'll throw it out there, and I hope it's taken the right way. We assume a certain amount of risk in this society. Maybe not a good analogy, but an analogy I'm going to make has to do with drunk driving. That kills far more people than anything we're talking about here today does. The way to solve drunk driving would say you cannot drink and you cannot drive. We do not do that. So my return to you is, why haven't we passed a law that says you can't drink and drive? And I think the answer is there is a culture, there are political realities, social realities, and we are in a certain point in time, using Erin's terms, a snapshot in time, and we're not ready to make certain leaps yet. I think that's as simple as it gets.
Gentleman here.
I have a question for anybody on the board. NR 151 is about to become law. It has addressed a huge problem. We're glad to have something change. But those of us who worked on the committees have said over and over again that it is not strong enough. Talking about adding more manure on our land when the manure could be moved to better land. Moving the manure is the key to keeping all these farms open. Their manure is taken out to their fields because of cost. If they had to move it to safer soils, they wouldn't have this issue. We wouldn't have this issue. Our wells wouldn't be impacted. Our property values wouldn't be impacted. Why can't the industry just move their manure, they own it, to better, safer fields, instead of coming up with this beautiful 2.5% reduction at soil depths of 2 feet? That's not going to work. It's not going to help.
Okay, I'm going to give that to Erin. We're almost out of time.
So my answer would be, it's hard to make those types of generalizations. You've got to look at the individual farm and what soils and fields they have available to them. And depending on which county you're in, these soil depth restrictions are going to impact greater portions of the county depending on where you are. And to say, why don't we just move manure to a different field? It's going to be a combination of things that are going to work for an individual farm, and you can't make that generalized statement.
I'm going to ask Grant to speak about the homeowner contract or whatever that, where homeowners have control over. We've spoken about that.
Maybe Susie had asked me what we do or can do above and beyond laws and regulations. I think one thing that we forget is that as a landowner, you absolutely control what takes place on your property. And an idea that Bill Schuster and I had maybe 5 years ago was to put together a joint effort where we drafted a boilerplate lease where landowners were leasing property to agricultural operators, and they weren't constrained by NR 151 or the statute. They could impose whatever requirements they chose on the people they were renting their property to. And I think it's one of the fundamental underpinnings that doesn't get discussed enough, as a lot of the property upon which activities take place, and whether it's manure spreading or something else, it's leased property, and people are allowing this to occur, and they don't have to. So I think a lot of this is within the control of the landowner. And in the context of manure spreading, much of the land upon which manure is spread is leased land. And if the landowners decided that they wanted to hold the operator to standards greater than were in NR 151, they have the absolute right to do so. And that's, one of the things, we aren't helpless here, that's just one example that where things can perhaps be made better by individuals making decisions about things that are entirely within their own control. It's just a matter of people thinking about that.
Can I comment on Mr. Swanson's?
Sure.
Just a comment to Mr. Swanson to go with what you said. I worked on a farm in Wisconsin where they were pumping the manure up to 7 miles. They had a sanitary sewer infrastructure, they had lift stations, they had an information technology group that managed all that. My point of telling you that is that I think you're onto something. I mean, I think you can move manure a long ways, just like you move water a long ways, just like you move human wastewater sewage a long ways. It's just that we need to decide as a society that that's an important investment.
The minute hand is getting close to the witching hour, so we are going to conclude this. We have covered a lot of ground this morning, dare I say groundwater. As you have heard the speakers say over and over, any action to protect this precious resource has been possible because of the political will of the community, by lawmakers who supported different measures when they were urged on by concerned and active citizens. And you all know that, you all are. So you have to continue that push. Continuing protection will require continued vigilance and action with each new challenge. Thank you for joining us this morning, and thank you to our terrific presenters.